Okay, so very good morning to all. Very good morning to all the participants. Actually, for your active participation, successfully we have completed first day. In first day, we had two sessions. In the inaugural session, we have many dignitaries, and in the first technical session, we had three invited talks. And for your active participations, actually, we do hope that the first session was successful, and we are very much optimistic. We are hopeful that today's sessions will be also very much interactive. It will be very useful, and you all the participants will enjoy the session. Your active participations will make the session a successful one. So we are very happy that today we have with us the distinguished educationist researcher from India and from Bangladesh. So we have first talk will be delivered by Dr. Subratanu Bhattacharjee, Associate Professor, Department of Physics, Kalyani University, West Bengal. That talk will be followed by Sri Shantanu Purohit, Assistant Professor, Department of Physics, University of Chittagong, Bangladesh. And today's last talk will be delivered by Dr. Bijon Dev, Assistant Professor, Ramkrishna Mahavidyalaya, Kailashar, Tripura. So without much delay, we are going to the main program of today's schedule. So I would like to wish, or I am requesting Dr. Rahul Bhattacharjee sir, please chair the session. So the second technical session or first technical session of today's curriculum would be chaired by Dr. Rahul Bhattacharjee, Assistant Professor, Department of Physics, ICPC College, Colonia. So please take over the session, sir. Over to you.
Thank you, Raghu. Um, as our conveners are informed already to all our participants that we are going to start our second technical sessions. And second technical session, we have three speakers. Dr. Subratanu Bhattacharjee, Associate Professor, Department of Physics, University of Kalyani, West Bengal, India. And second speaker, which will be start from 11:45 to 12:30, Shantanu Purohit, Assistant Professor, Department of Physics, University of Chittagong, Bangladesh. And our third speaker, Dr. Bijon Dev, Assistant Professor, Department of Physics, R.K. Mahavidyalaya, Kailashar. So I welcome you all the esteemed speaker. I welcome and the participants who are eagerly waiting to hear something from our learned resource persons. So we will start our program from 11 sharp at 11 to 11 p.m. and our first speaker will speak on the topics innovative electrolyte for lithium metal batteries. Let me introduce our first speaker to our uh, participant, Dr. Subratanu Bhattacharjee, currently working as an associate professor, Department of Physics, Kalyani University. He did his master degree from North Bengal University and PhD from Jadavpur University. His research interest mainly lithium batteries, sodium ion batteries, hybrid supercapacitors, functional nanostructures, and ion gels, etc. He has many international and national collaborations like IIT Kharagpur, VIT University, ISCS. He produced two PhD students and
Not two, four actually.
oh, acha. So
It's old
now
data.
it is old data.
Four.
It's
Yeah.
four. Sorry, and also he is a recipient of postdoctoral award in National Taiwan University of Science and Technology 2005, recipient of DST SARC Fast Track Young Scientist Fellowship 2010, recipient of Postdoctoral Fellowship Award in National Taiwan University of Science and Technology 2005, recipient of Research Associateship Indian Association for the Cultivation of Science 2005, recipient of CSIR Junior Research Fellowship 2002, etc. So he published many peer-reviewed journal, and list of publications for last 5 years is 27. So I welcome you, sir, and this virtual platforms is yours. So, sir, continue your speech.
Thank you, Dr. Bhattacharya. So, first of all, I would like to sincere thanks to the organizer to give me the opportunity to talk over this international e-conference platform. And as I have been informed by the convener that most of the listeners, means audience, are students of undergraduate and postgraduates and some research scholars and others. So my talk actually, the name was Innovative Electrolytes for Lithium Metal Batteries. But I thought that rather to emphasize on research, I would like to explain everything regarding lithium batteries and energy storage system, and that will help the students to understand what is going on in lithium batteries and in research areas, and my interest to motivate them towards the research, and specifically research in the energy storage materials, which is actually the burning stream in the research area now. Nowadays, it is just everybody wants to work on energy storage or energy, renewable energy, etc., etc. So, without much delay, I just want to share my slides. Okay. So I think you can see my slide. If it is not visible, please tell.
Yes, sir. It's not still now. It's not visible.
Okay. 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 I understood what happened. Yeah. Now I
Yes.
think it
Yes.
is visible.
Yes.
Yeah.
Yes. Yes. Wait a second,
Okay.
sir.
I think it is visible now.
Yeah. Yes. 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 Innovative electrolytes,
Yes.
lithium metal.
Yeah. So. So before entering into my topic, I just want to introduce my university. That is the front gate of the University of Kalyani, and this is my department actually. And I am Dr. Subratanu Bhattacharya, working as an associate professor in the Department of Physics, University of Kalyani. And this is our department actually. We offer MSc in physics 2 years, postgraduate degree, fourth semester system, with an intake capacity of 72 per semester. And we offer specialization in nuclear and elementary particle physics, solid state physics. I am from solid state physics actually, and electronics. And we offer also PhD degree with some specialization like experimental and theoretical condensed matter physics and material science, experimental atomic and molecular physics, theoretical statistical mechanics, nuclear and particle physics, phenomenology, and many other things. I could not include all. So, with this very brief preamble about my department, I am entering into my topic actually. That is the energy and power. That is the main topic actually. It's the law of nature. You may know that if you are a powerful guy, then your power may not sustain for a very long time. Means power, you can see that time is actually is divided by time. This Q into V by T. And on the other end, energy, if you see, it is actually multiplied by time. So it's if you increase if you decrease time, your power, actually power cannot sustain for a long time. It's a very small time matter. Like you can consider Winston Bolt, he can run 100 meter with a very fast, high pace. But if you ask Winston Bolt to run 1 kilometer with the same speed, it is not possible for him. On the other end, consider a marathon runner. He can run 4 kilometer or 10 kilometer with a constant speed, with a high energy. Because how can he sustain this kind of energy? Means he don't require a lot of power to sustain that energy. Because everybody we know that if you start a marathon with a very high speed, you cannot sustain. Okay, you have to start with a constant speed, and you have to maintain the speed up till the end, so that you can don't waste your energy or power, so that you can continue your performance. In that way, the devices, the storage devices are also divided. And I'm coming to that point. In the world, the same thing, this is the law of nature, that high power devices cannot sustain very long time. These are supercapacitors for energy storage devices. They are classified as supercapacitors. And in long energy storage system, they are classified as battery. So battery are high energy devices, not high power devices. But supercapacitors are high power devices, not high energy devices. And in all the respect, the storage capacity we actually define by ampere hour or milliampere hour, and electric energy stored, that is milliwatt hour or megawatt hour, and the efficiency is the ratio between charging and discharging. You all know, being a physics students, I think we should not mention it like. So on the basis of this preamble, the world is actually classify the storage techniques into these categories, and all the storage devices are actually belong to all these categories written here. And that depends upon based on discharge duration first and form of energy stored. So discharge duration means short term, medium term, long term. So short term means this is high power devices, and long term and medium term are low power but high energy devices like batteries. And form of energy stored, these are mechanical. These are very big cases like pump hydro storage, compressed air energy, etc., etc. In our domestic and industry are actually run by this kind of pump hydro storage, compressed. So energy we actually stored, we cannot generate. Actually, we know the law of energy. Nature actually prevent to generate energy. It can only allow us to convert energy from one stage to another stage. So in this conversion we can store. So in pump hydro storage also we can store some amount of water in a high. Just you know everything, I think, all. So our concern is in the electrochemical storage device. Now today I am going to talk about the electrochemical storage device, specifically in the secondary batteries, that is the lithium-ion batteries. And there are the electrical double layer supercapacitors and chemical fuel cells. You may heard about this: water electrolytes, biomass generated gasification, thermal storage water. These are all kind of storage devices actually. So just I am concentrating on that as this is my research area. So I am concentrating on secondary batteries, that is the lithium-ion batteries. And if you consider the power assessment, that is very important. And based upon all the device activities, you can see again that is actually on the basis of nature restriction, that high power density you can achieve with the means you have to go with a very low energy density, and you have to compromise with the energy density to achieve high power density. On the other hand, if you want very high energy density, then you have to compromise with the power density. You can see For fuel cell, that is the high energy density device, it has only power density 10 watt per kg. And if you consider lithium battery, almost a balanced factor. It's to some extent better scenario for lithium battery. This high energy density is around 100 watt hour per kg with a moderate, not very high, but moderate, like 10 to 1000 power density. What is actually required, we are heading towards, is that region where we can achieve, we can we want some device which can provide us 1000 watt hour per kg average energy density with at least 10,000 power density. So we are actually fighting with the nature's law, against the nature's law actually. So many progress worldwide are going on. A lot of research works are going on. So I'm just emphasizing some of the key issues which are actually preventing us to achieve this kind of devices. So just I want to show what is actually energy storage system. I think most of you are already aware of this, that energy storage system have some anode and some cathode and an electrolyte with a separator. If you don't know, you just understand this. And I'll show one animation how lithium battery will work. It's actually, so cathode means which actually source of ions. That is, in case of lithium battery, it's a source of lithium ions. And anode is actually where the lithium ion during charging can be stored. And in discharging, that anode actually provide the lithium ion through the electrolytes, and in the outer circuit, the current will flow through the load, through the device. In that way, actually, energy storage system works. I'll show the animation. You can get it in a better way. And how the term that primary and secondary batteries, because I already told that I'm interested in secondary batteries. So is there any primary batteries? Yes, of course. Primary batteries are batteries which are actually not rechargeable. Non-rechargeable batteries are primary batteries. So we usually use in computers, in watches, in everywhere. We use this CR2032 batteries. This is our lithium batteries, the standard battery. CR20 means 20 millimeter is the diameter and 3.2 millimeter is the thickness. In that way, the name. There are other batteries also, 2025 batteries and all. As thickness is small and like. So the main thing is that in that batteries, lithium metal is actually used as anode. That is the main emphasis. You just take a note of this, that lithium metal is actually used in the primary batteries as anode. This is a sealed batteries, and that will discharge one time. And this is already charged when you buy it from the market. It is already charged and it will discharge like this. It's around discharge around 3 volt, and after that it will decay, and it will last around say 1200 hours. So it's a very nice, but it can only discharge. It's a fixed discharge of 0.19 milliampere and 2.9 volt. So that's all. This is about the primary batteries. And in the secondary batteries, you can see there is the things to be understood. So this is a normal secondary batteries used in Samsung battery mobiles and others. You can see there are many things is written here. I'll explain one by one later. So what is actually within these batteries? In the batteries, instead of lithium as anode, graphite is actually used as anode. Graphite. That is the main difference between primary and secondary batteries. And there are electrolytes Electrolytes, I'm coming to that in detail, greater detail, because my emphasis will be on electrolytes only. And there are cathodes. Cathodes are actually composite of lithium and oxygen, lithium cobalt oxide, or lithium iron oxide, and many other. So a lot of people are actually working on cathode materials, and a lot of people are working on anode materials, and a lot of people are also working on electrolyte materials. So the world is in lithium battery research world is actually divided in three categories. One portion is working on cathode, one portion is working on anode, and like us, I am all very little contribution I have already made to this world. A lot of people are working very nice. So we are actually interested in electrolytes. So electrolytes are very important. I am coming to that. But before that, I want to discuss something about what is actually written here. That is the nominal voltage, watt, charged voltage, that is mAh, everything I will explain. I will be happy to answer any questions from you at the end of this talk. So this is the animation what I am actually talking about. So this is the working of a lithium ion batteries. This is actually current collector. These are metals, copper and aluminum current collectors. On that current collectors, these are graphite, and these are lithium cobalt oxide or lithium iron oxide or something like that. These are the composite electrode material, cathode material. And this is graphite, this is anode material, and this is called full cell material. And in between there are separators. Separators are permeable membranes. So with membranes with very small hole, and these are insulator, and in between they are full of electrolytes. So electrolytes, what is the purpose of this separator? So that anode and cathode cannot be short. Okay, just to separate with an insulator in between anode and cathode. And there are electrolytes. So during charging, this is the charging where lithium ion is actually coming from cathode, going through the permeable membrane and stored in the anode. Okay, so these are lithium are coming to anode. It's actually form a compound that is called LiC6. This is lithium and graphite, means carbon compound. Graphite is nothing but carbon. So LiC6 actually form, and this is during discharge. So when you give some load in your mobile, you running some app or something like that, the discharging happens. And this discharging actually depends upon how much current you actually using. Like suppose you only use your mobile for say call, or not use internet, not use any WhatsApp, not use any game, not play any game, not see any video or movie or etc etc. So your battery will last long, because you only use for calling purpose, and you only discharge your battery for very small current. That is very important to understand. But if you use every features in your mobile, how long the battery will sustain? Only merely 1 to 2 hours, or maybe 3 hours. It depends upon the capacity. Maybe 6 mAh battery, or 6,000 mAh battery, 5,000 mAh battery is now coming. I'll talk about it on greater extent. But first of all, you have to understand that every discharge current will determine the life of your battery. Okay, every discharge current. So if you discharge it in a high rate continuously, your battery will not last very long. That is the first thing you have to remember about lithium battery. And that is the electrochemical. These are actually electrochemical energy storage device that I have already mentioned in the classification. So this is the reaction. You can see this is the electrochemical reaction. occurred in the cathode. This is the cathode material, LiCO2, if you consider. Then one lithium ion actually ejected from the cathode and with electron in the outer circuit. Okay, this is during charging. And during discharging, this is the electron flowing through the load. If you consider this is a load, and in the inside there are flow of lithium again from anode to cathode. There comes the main issue, that how much ions is actually moving from anode to cathode. If there are 100, suppose if you consider that during charging there are 100 ions that comes from cathode to anode, is there 100 anodes which are coming completely from cathode to anode? No. That depends upon electrolytes. That depends upon the electrode-electrolyte interface. That depends upon the compatibility between the anode and electrolytes, cathode and electrolytes, and a lot of other issues. So these are the actual parameters which actually control the capacity or efficiency of a lithium-ion battery. So overall picture is like that. LiCO2 plus C, N, Cn is the graphite, is actually charging during charging and discharging. This is the electrochemical reaction. And how can you determine the battery capacity? That is actually given by the law of Michael Faraday. This is called Faraday constant. One electron is coming, one ion is coming. This is the electrochemical law. And the specific theoretical capacity. This is very important to understand. What is theoretical capacity? Theoretical capacity is the maximum capacity, maximum achievable capacity from a cathode material. Means for a cathode material, how much capacity you can maximum you can achieve. Like I told you that if you consider 100 lithium ions are coming from one cathode material. So this 100 lithium ions means how much capacity? That will be the theoretical capacity. So for example, LiFePO4, this is the discharge, okay, electrochemical discharge reaction. So you can see, if you consider if the Faraday constant is 96500, finally you can obtain the theoretical capacity as 170 mAh per gram. 170 mAh per gram. Gram means that is the active material capacity, weight of the active material. How much electrode material you actually use in your battery. That depends upon the size of the battery. In coin cell, the active material is very small, and in the pouch cell or in the big battery cell, the material is very high. But if you consider specific capacity, you have to multiply with it in your with the amount you use actually. Then you can find the total capacity. Your battery with this LiFePO4, you cannot get 170 mAh per gram practically, because there are some issues. So you may achieve up to 160 maximum if it is an ideal condition. If you consider a just purchase a battery, okay, but after say 550 discharge cycle, you may achieve only 140, and it will gradually decrease depending upon your charge, discharge, use, how you are actually charging, how you are actually discharging, how much cycle you have already destroyed, and something like that. So a lot of issues are there. I am not going in detail in that. So this is the discharge capacity, discharge current into discharge time. And of course, discharge current is the main thing which you have to remember, that I already told. For a smart battery, discharge current actually determined by the number of amps you are using. If you use a huge number of amps, then your discharge current is very high and discharge time will reduce drastically. And if you use a low amp, then it's okay. Means your discharge time will be long. It will sustain up to a certain time. and so on. So now I am coming to these terms which are actually written in a battery, like nominal voltage 3.85 volt, 5.20 watt, charge discharge voltage is 4.4 volt, charge voltage 1350 mAh. You can understand this now, that what is 1350 mAh? This is the total active material into the theoretical capacity. Multiplied with that, you can get 1350 mAh. Now it is 5000 mAh battery, means you have to use more active materials for that, etc., etc. So if you find the in a battery, if you monitor the charging and discharging cycle, this is actually given by a battery cycler. Actually, this is an instrument which we have. For the research purpose, we have to use a battery cycler to test the performance of a battery. So this is actually the charging. Charging starts from 2.5 volt and it can last up to 4 volt. You can see this is the charging. And from discharging, it can start from 4 volt, as this is the charging up to, we have charged at 4 volt. From 4 volt, it can go for say, okay, just a minute, it can go for just a minute, okay, you can see it can last up to say 2.2 volt or something like that. So anyway, what I want to say, that you can see there is a plateau in this region. That is the most important region in a battery. In this plateau region, battery actually works, because that will not work here and that cannot work here. So in this plateau region, the battery actually works. And in this plateau region is actually determined by the nominal voltage. That is the voltage between the maximum charge voltage and typical end of discharge voltage. This is around 3.3 volt and this is around 4.4 volt for this battery. For my battery, the nominal voltage is like 4 volt plus 3.5 volt by 2, and you can see 3.85 is actually 4.4 plus 3.3 by 2. This is the nominal voltage, nominal cell voltage, where actually the plateau region occurs. So, and then battery will work at a nominal voltage and a current of whatever is being down from it, and 1350 milliampere hour battery can deliver 1350 milliampere current for 1 hour. This is called 1C rate. Means if you use 1350 milliampere current for 1 hour, you can get it. Okay, you will discharge it within 1 hour. And if you use 675 milliampere, if you use this just by half, then you can increase your battery life by 2 hours. This is called 0.5C. And for 337.5 milliampere, if you use, then you can get 4 hours of battery life. And 2700 milliampere for 30 minutes, and so on. Means 27 milliampere means you double your current. So your battery will last only 30 minutes, and so on. So in that way, battery actually works. So I expect some questions from here, maybe later. And what the nowadays the research is actually, the battery is actually nowadays is now. So these are the anode materials. So anode actually carbon, that is graphite, hard carbon, MCMB, and graphene. Mainly graphite is actually used in commercial batteries. I am talking about commercial batteries. And lithium metal oxides, these are LiCO2, LiNi, these are composite, these are high voltage electrodes, and these are LiMn2MnO3 and LiMn2O4 and LiFePO4. LiFePO4 is most used battery cathode, and in commercial battery usually you will find LiFePO4 and graphite. But what if we use, like primary battery, if we can use lithium metal as anode material? what is actually restricting the use of this lithium metal? That is the focus of the research nowadays in lithium batteries, because this graphite actually have the theoretical capacity only 372 mAh. I'll show that lithium is the lightest metal with specific gravity of 0.53 gram per centimeter cube, and with a very high energy density. Its theoretical capacity is 3860 ampere hour per kg, which is well above 10 times higher as compared to graphite. This is only 372 ampere hour per kg. So if you can use lithium, our total scenario will change. Okay, but till that we could not use lithium as anode, and the research is only focused on this, how to use lithium as anode material in batteries. That is why this is called lithium metal batteries, we can tell these batteries. And nowadays what the lithium batteries you are getting, this is called lithium ion batteries, where graphite is the anode, not lithium as the anode, as you can get it in the primary batteries. Okay, so not yet implemented commercially due to safety. What is the safety matters and from where it is coming? So now the electrolyte part is actually I am talking about. So the safety is actually depends upon the use of electrolytes, what you are using. So ideal lithium battery electrolytes, actually what actually electrolyte do? Electrolyte plays a key role in transporting the positive lithium ions between cathode and anode. During charging, it comes from cathode through electrolytes to anode, and during discharging, it comes from anode to cathode through the electrolyte. So an ideal electrolyte should have these properties, like it should have good should be a good ionic conductor and electronic insulator. Means if it is a electronic conductor also, then electrons will attack the lithium ions, and you will get lithium metal instead of ions. So it should be totally insulator for electronic conductivity. Next is it should have wide electrochemical window. That I have told that we can charge up to 4 volt nowadays. If we can charge up to 5 volt, if we can charge up to 6 volt, then our energy density will enormously increase. So people are working on high voltage electrode. That I have already shown, that the composite electrode, that is the high voltage electrode. So it should have wide electrochemical window to adjust with that high voltage electrode. If your electrolyte has a low voltage window, then what is the purpose of using this high voltage electrode, right? It should also be inert to other cell components, because if your electrolytes start reacting with cathode, with some anode, so all are exposed to the electrolyte. If it itself start reacting with those, then your battery will be corroded. So in that way, it should be very, very inert in terms of the reactivity and toxicity and other things like cell separators. If it start coating cell separators, it will turn, and in that way the cathode and anode may shorten and something like that. It should be thermally stable, because in the extreme condition your battery may be become hot. Like you can see when you talk with your mobile phone, your mobile become hotter. So if you use some volatile electrolyte, then it can burst, which happened already for many cases. Like your laptop burst and your mobile burst and everything. It happened already. Nowadays, some precautions has been made so that this kind of accidents actually can be avoided right now. I'll tell something about it. And most importantly, it should have high lithium ion transference number. Lithium ion transference number, that is the main term for a lithium ion conducting electrolyte. Means this ionic, you can tell, okay, ionic conducting, high ionic conductivity. But if you say, if you consider that electrolyte, if your electrolyte is actually nothing but a solution of a salt, that is lithium salt, in a solvent. So lithium salt has both anode, anion and cation. So you can get anionic conductivity as well as cationic conductivity. You can see this is the diffusivity of cation. This is the diffusivity of anion, and this is the diffusivity of cation. So transference of cation is the ratio between the diffusivity of cation by the sum of the. So if you can neglect this diffusivity of cation, then your transference number is 1. Means you can get ionic conductivity only because of cation. You can understand this. But if it happened that somehow your anionic conductivity become higher than the cationic conductivity, then your transference number will be very low. So this is, maybe it is highly conductive, but who is actually contributing this conduction, ion conduction? The anion instead of cation. But your goal is to conduct lithium from cathode to anode. But what you are getting? You are getting anions are actually moving, cations cannot get any chance to move from cathode to anode. In that way, it can hinder the process. So you may not get high capacity, or your battery will die out very fast, and something. Many things can happen. This actually happened. And fast charging. Nowadays, all are in a hurry. We don't have time for charging the mobile, but we always want mobile to work. But what is actually preventing? That is the charging time. So we usually we want to use the C-type capacity. Now C-type, that charger nowadays, USB based charger. In the last slide, maybe or second last slide, I actually has given this charger type, and how actually company is making fool by giving this kind of charger to the consumers. That I'll explain. But if you use with low lithium transference number, and if you use fast charging, there is a gradient of, this is, you can see there is a voltage gradient, because the slow means low lithium transference number means cation cannot move, but anions are going very fast during fast charging or high current. So there is a potential gradient occurs, and this potential gradient further decrease your cation movement. In that way, your battery is basically totally wastage of effort, and everything will be lost. In that way, things are going very worst. So this is actually how the electrolyte interface actually work, as you can see. So these are the lithium. This is the lithium ions actually, and in front of the anode, this is the graphite. There is a layer formation, always happened in the first discharge or first charging, first charge discharge. In first 2-3 charge discharge cycle, there is a protective layer. This is called solid electrolyte interface that actually formed in the battery. But if you use okay, now what is the conventional solvent for lithium battery for the electrolytes? These are aprotic solvents. These are called propylene carbonate, ethylene carbonate, vinyl carbonate, FeC, DMC, lot. These are very, very volatile and flammable. And you may heard of this battery burst or laptop burst, or this is actually a battery car which is actually burst with this kind of solvent use. And if you use lithium metal as anode, there is another problem which can actually arise. This is it's called lithium dendrite formation, and I'll show you something like that. That this is actually lithium metal anode, and how this lithium dendrite formed and how it leads to a short circuit, that I'll show. And you can see this is the lithium metal, and this same solid electrolyte interface formed, but these electrolytes, that ACI is actually now extending. These are lithium, these are called dendrite, lithium dendrite formation. And during charging and discharging, it actually start increasing. It is coming towards cathode to anode, and now it becomes short. So that actually the main problem why lithium metal you cannot use with the conventional electrolytes. So you have to change the electrolytes in order to improve your lithium battery performance, or if you want to use lithium metal as your anode. So people start working on room temperature ionic liquids, and we are also doing that. And these are the room temperature ionic liquids. It's a chemistry part actually. I am also very poor in chemistry, but somehow I'm surviving with very poor knowledge. So what is ionic liquid? You can see this is a sodium chloride. This is a ionic salt. So ionic liquid is nothing but ionic salt, but they are liquid in room temperature. That is the simple definition. Lithium salt, NaCl is a ionic liquid, but its melting point is around 803 degrees centigrade. So you cannot tell these are room temperature ionic liquid. But this is an anion, if you can use, and this is a cation. You can see these are very bulky. This is an organic cation, and this is organic anion. And if you prepare a material, this is like this is anion and this is cation, that actually liquid at room temperature, even at a room temperature like that. Okay, so this room temperature ionic liquid, actually people start working as solvent in lithium battery. Why? They have beautiful properties. What kind of properties? These are the different classes. This is actually the ARPTTTPP ionic liquid, which are usually suitable for lithium-ion batteries and supercapacitors. ARPTTTP means which does not have electron, hydrogen. Instead of hydrogen, there are lithium. Okay, so these are organic, conventional organic electrolytes. These are ARPTTTP that I have already told, EC, VC, DMC, and others. These are very flammable. If you ignite, they will immediately catch fire and burst. So the accident can happen. But in ionic liquid, you can see they never catches fire. These are ionic liquids are very stable, thermally stable. So you can use it without any hesitation. But there are some constants. Moderate ionic conductivity first, high crystallinity, decrease in ionic conductivity, and lithium ion transfer capability with increasing lithium salt. Because if you add lithium salt in that solvent, their viscosity becomes very high. You know, viscosity is detrimental for ion movement. So if you increase the viscosity, your ion mobility will slow. We have done some work on that. I'm not going in detail in that because that may be difficult to understand for you, specifically for the undergraduate students. And so what we have done, we actually removed the crystallinity of ionic. We able to do that. We have removed the crystallinity of ionic liquid by incorporating some nanoparticle. This is surface modified nanoparticle, rather surface modified by ionic liquid species and then incorporating this species to ionic liquid. That happened by accident. That happened by accident. We are just trying to get something else. But what we got, that even increasing the viscosity, we are getting conductivity, very high conductivity, and that actually these are the DSC who are aware of that can only understand. They can only understand. This is actually the crystallinity graph, and after some time we have seen that we got the ionic liquid completely amorphous ionic liquid instead of crystalline ionic liquid. And this amorphosity arises due to the incorporation of surface functionalized nanoparticle into it. And these surface functionalized ionic liquid based amorphous nanofluids actually show beautiful properties, that even if you increase the viscosity, their conductivity increases up to a certain extent. Their conductivity does not fall with viscosity increases, increment of viscosity. That we actually used in lithium battery. Okay, and we successfully just these are I don't know whether you can understand. You can see this is very important. This is the temperature dependent viscosity plot. Actually, this is the viscosity. You can see with the temperature viscosity increases. Simultaneously, it should decrease conductivity, but conductivity also increases up to a certain extent, not monotonously, but up to a certain extent, up to say 7.5 weight percent of nanofluid incorporation, we get that viscosity. In spite of increasing viscosity, conductivity increases substantially. And we have used in the lithium battery, and we get very high quality battery performance with lithium ion transference number around 0.64, which is very high as considering the for carbonated solvent, where it can be only T plus value is 0.23 in conventional electrolyte solvents. So instead of 0.23, we got 0.64 in ion fluid based electrolyte, and that is actually published in a very high quality journal. And we get the performance. You can see these are the performance, battery performance. I don't know whether you can understand it or not. These are normal ionic liquid based electrolytes. You can see only 0.2% lithium salt can be added in that, only 0.2. Even though as the salt concentration is very low, the battery performance is also very poor. The theoretical capacity is around 140 for this particular cathode, but only 90 mAh could be achieved for normal lithium ionic liquid based electrolyte, whereas if we use ion fluid based electrolytes, you can see there is a capacity fading also. In the second cycle, 20th cycle, it comes to 80, and in the 50th cycle, it's less than 80 actually for ionic liquid. And if you increase current, you can see there is a capacity fading. It always happened because you are not moving 100% ions from cathode to anode, anode to cathode. That's why at high discharge current, you are getting capacity fading. Even at high discharge charge current, you are also not getting what capacity you should achieve. You can only achieve capacity up to a certain extent, means near to the theoretical capacity, if you charge or discharge at a very slow rate because of your low lithium transference number. So only way to improve it is to increase the lithium transference number so that you can get high capacity with substantially high current. I don't know if you can understand it not, but for our case, you can see we have achieved nearly the theoretical specific capacity in the first cycle, and even at 50 cycle there is very small capacity fading. And at a high, substantially high current density, we only 80 up to up to 80 mAh we have achieved, which is actually achieved for normal ionic liquid based battery at fast discharge at very small current. We get it 4 times higher current density. So in that way we actually prepare something which I now coming to nowadays lithium polymer battery. We have done also a lot of work in that area, but we did not mention it in this talk actually. So nowadays you can see the lithium polymer battery is under use in the mobile, where you can see the sealed back cover. You cannot remove the battery. Why? Because the polymer is very sensitive to water and moisture. That's why the portion is sealed. Its inside is something like that. Okay, and usually you use Type C phone charger and capacity fading occur. You cannot understand that. So what happened in this Type C charger, that is just for information, in USB 1.0 and 2.0 specs, that is normally used in a slightly older version of these chargers. The standard downstream port is capable of delivering up to 500 milliampere, that is 0.5 ampere current during charging. And if you can see, even at 96 mAh per gram, a milliampere per gram, you can see how the capacity fading occurs. So you can understand what is actually your battery is getting during this charging. You can see your battery is fully charged, 100% charged, like this. Like this is 100% charged. But how much capacity you actually achieved? Lot of lesser capacity, what you should achieve in a slower charging current density, charging current. Okay, what I mean to say, if it is 100 milliampere charging current, you may get much longer battery life with respect to this C type capacity. But nowadays everybody are in hurry, so USB 3 charger, this is 26 volt charger now have come, and it moves up to 900 milliampere current. Even worst, you are thinking that my battery is charging within half an hour, within 1 hour. Full charging I can get within 30 minutes. But what you are getting, your battery will drain even faster, because you only achieved very small capacity in your mobile. So you can notice that after full charging, your battery will discharge, die out within a very small time. But before, if you charge it with a normal non-C type port, non-USB type charger, that is the normal charger, your battery would last very long time. But it can charge with a very slow current, and it will take at least 1.5 hours or maybe 2 hours to full charge. That is the required charging, because your transference number is very low. So now people are working on that, and there is another very important area where people are working, and also we have started working on that. That is called single lithium ion contactor, where no anion will contribute in the conductivity. Only cation will contribute. But the problem is that we are not getting high ionic conductivity, because we are not getting sufficient mobility to move the lithium ion. Everything is fine, only the ionic conductivity is very low. So this is the dual ion conductive solid polymer electrolytes, where you can see the lithium ion transference number is very low and other things are very low. Solid electrolyte, you can see the flexibility and interfacial contact is very low, but conductivity is high. So That is the future of these lithium ion conductor electrolytes. And this is the polyanions which I am talking about. You can see you immobilize the anion and only mobile lithium ion you will get. But somehow the people are working on that. We are also working on that. Somehow we have to get at least some mobility in this lithium ion so that we can improve the ion conductivity up to a certain extent so that we can get the lithium ion performance. But that performance will be wonderful performance if we can achieve it, because we can truly get a high discharge high charge, high current charging, maybe up to 15 minutes or 30 minutes with full capacity. That is the main important part. Now you are getting high fast charging but with half capacity. If you can increase the transference number up to nearly 1, means total lithium ion conduction, then you can achieve high fast charging with full capacity. So that is the research opportunities in the field of lithium battery. And in my lab also, if someone is interested, I welcome if they have their own fellowship like CSIR, UGC NET or something. You can see the material design with higher conductivity, and then better electrochemical stability, and then electrode design, then battery technology. And we are actually heading towards lithium silicon battery that I did not mention anywhere. Lithium silicon battery is another kind of battery which we are actually working on it. My new project, I'm having one project funded from ACRB. This is actually on that we are developing a battery where lithium is working as cathode instead of anode. Okay, lithium will work as cathode and silicon will work as anode. So that will be the minimum if it can be achieved. Some people are working in that area worldwide. If we can achieve it, our minimum specific capacity will be around 2000 mAh, which is huge considering the present scenario. So that is all. I wish if I can answer questions from you. So thank you for listening.
Thank you, sir, for your kind, for a beautiful deliberation. So many questions are coming, so that's why I understand
Definitely,
how the
I'd
people
like
are interested. How people are interested. I pick few questions. Very one of the participant, and forget the name. He is now interested in doing the research in the field of batteries, and so many common questions are also we are getting, like why lithium. What is the advantage of lithium? I think you answered in this between. You
I
answer
have
in
already
between this.
answered it.
If they follow, then they will get the answer why the lithium. Any
Just telling you this, just to
yes.
show them.
Mm,
Okay, let me come to this slide. Yeah, this is why lithium, and this
why
is the
lithium? Yes.
because this is very high theoretical capacity. You can see.
Yes.
Instead of graphite, graphite is only can deliver 370 ampere hour, instead of lithium can deliver 3860 ampere hour.
Yes.
So it's
Yes.
huge. Okay.
Any alternative material than lithium?
Yeah,
Then
definitely. There are sodium batteries are there. People are
sodium
working
batteries.
on that. Yeah, zinc batteries are there. People are working on that. But the performance is not up to the mark till now, and there is no commercialization, and still a lot of work to do. We are also doing a very little on that
Yes.
sodium
Yes.
and battery, but it's very difficult because sodium, size is very high as considering lithium. So
Yes.
the size means high, bulk size means ion mobility is very low. So that is the main problem. Means intrinsically you are getting low mobility. So other problems are there. So you can see the success rate is very low.
Very low.
So
Mhm.
yeah.
People are doing research on this, and very
But
common
why?
question. Uh,
Yeah,
mm,
but one thing I should mention, that
mm,
if people can succeed
mm,
to develop sodium battery, the
mm.
battery price will be very low. Why?
Oh.
Because sodium is
Mhm.
very abundant, but
Yes.
lithium is very costly. Only few in the world, only few countries have that lithium
Lithium.
resources, like
I think
Australia,
China.
China. Yeah,
Uh,
Australia and
mm,
China and others. And in India, we have to import lithium from other countries. That's
mm,
why lithium battery is so costly in India.
costly.
But
Mm,
in if you can achieve, we can develop the sodium battery, so the
yes.
price will be very low, because sodium is
Yes.
abundant, most abundant
Mm,
in the
yes. Yes.
nature. So
And
that is the
also you
thing.
mentioned organic electrolyte, organic. If you use the
Yeah,
organic
yeah,
type of system,
yeah,
then
yeah, yeah.
another and interesting, because they want to know about in vehicle that we are using in battery in vehicle. What
Yeah,
type of
definitely.
what type of
If
batteries, and what are the improvement in futures we
No, no,
can.
no. The thing is that
Mm,
there in vehicle you have to
mm,
use grid-based battery. Okay, only
okay.
one battery will not serve the purpose, and
Mm,
that is very risky actually. So they use stack battery stack. Okay,
it is
so like 16 batteries, 20 batteries, battery. This is called grid-based battery grid. So in
very.
commercial vehicles,
Mm,
that is electrical vehicles and others, they
mm,
use battery that grid battery, and these are all made of this kind of materials only, but in a larger
mm,
size.
size.
Okay, so that I have already told, that specific capacity. If you
Mm,
use your active material, increase your active material, you can get better capacity. That's all.
better.
But
Mm,
specific capacity is the same per gram.
mm,
I have
mm,
mentioned. Okay,
mm,
if
mm.
anybody can follow, then you
So,
can understand.
so many questions also. They are C type. Why there is people, fast charging is not already you answered. Still, people are
Hmm.
asking why where you are using C type of charger, means 3.0,
No,
and why
no.
you not
C
use.
point, yeah, that is the thing, that
Mm,
why C type charger company are providing.
mm,
Company providing according to the consumer needs. Consumer
yes.
requires to charge the mobile within a very
Mm,
short duration. Okay,
short duration.
company provides C type charger, USB
Yes.
type charger. Okay,
Mm,
so that high current
mm,
can go through your battery during charging, but
yes.
high current always encounters capacity fading. That is why I am telling that people
Yes.
are actually getting full. You can
Full.
see, if you charge with 24 mAh per gram, milliampere per gram,
Mm,
you can
mm,
get the charge capacity like that.
mm,
What is the charge capacity? 140 mAh
mm,
per gram. Okay.
mm,
Now you
mm, mm.
increased 96 mAh milliampere. Charging with 96 mAh milliampere per gram.
Mm, mm,
What you are
mm.
getting? Only 80. But you are
Yes.
satisfied because your
Yes.
battery will show
Fast
it
charging.
is fully charged.
Fully charged.
Your battery will show fully charged.
Mm,
But with what capacity? This is only 80 mAh per gram.
mm,
That is the C type charges is actually doing. You are
mm,
not getting full capacity. That is, you are actually losing 60 mAh. That is why I
mm,
am saying. That is why I am indicating that
mm,
don't use. I cannot say that don't
mhm.
use C type charger, but
According to needs.
according to needs, you have to use
Mm,
it. But you are actually losing. What?
mm.
How? That I have explained. That is the
Yes.
thing.
So I think all of our participants got answer from our resource persons, and if any questions you have, then you can send Sir mail. We will provide you the mail address, and Sir
Yeah,
also
definitely. I'll be
offer
happy.
you. Sir will offer you to work if you wants to work in lithium-ion batteries are doing work. So if you of any of our participant who is doing graduations, I'm interested in doing research, then you can do research. It's a very prominent and also commercial is an there is a
Yeah.
commercial
This is
viabilities there.
very,
So
very, emerging subject,
emerging subject.
research
So
survey. Yeah, yeah.
yes, student can choose this subject as a career, as a research in lithium-ion battery. So very interesting, and I think all of our participants benefited with this talk. And because of time constraint, we are going to for our next
Yeah,
next speaker. So thank you, sir, again, and hopefully we'll meet again and few see you in future in also in Tripura. You please visit in the Tripura, and we
thank
have
you,
the
thank you, thank you for
university.
inviting.
So if you find time, and after pandemic, please visit Tripura, and we also welcome you in this region of India. Thank you, sir,
Okay,
once again.
thank you very much. Okay.
So let us.
So I am leaving. Okay.
Yes, sir, yes, sir, yes, sir. So next we have, uh, as you know, we have our next speaker, uh, Shantanu Purohit. So I welcome you, sir. I, on behalf
Good
of
afternoon.
organizing committee, good afternoon, sir. I welcome you in our virtual platforms. All are waiting. Our students are waiting. We hopeful that our lectures is very good. Our the way we are going is very interesting. So let me introduce our second speaker. Today's second speaker to our esteemed participant, Shantanu Purohit. He is now working as Assistant Professor, Department of Physics, University of Chittagong, Bangladesh. Sir did MSc Physics from same University Chittagong in 2014. His research interest mainly medical physics, nuclear physics, and statistical mechanics. He is a member of Chittagong University Physics Society, CUPPA Bangladesh, Medical Physics Associations, and sir topics is advancement of physics research and technology teaching in pandemic period, dosimetry in small field. So I welcome you, sir, once again, and this virtual platforms is yours. Um, Once again, all from the organizing committee, I welcome you, sir.
Thank you. Good afternoon, everyone. At first, I checked my file. Is it here?
Yes, it's not coming still now. I'm looking at. Yes, yes, yes. Now it is coming.
Okay, thank
Yes,
you.
yes, yes, yes.
So, thank you, everyone, for welcome me in this e-conference organized by Department of Physics, Government Degree College, Dharmanagar, North Tripura, Tripura, India, in collaboration with Department of Physics, Women College, Agartala. And this is Shantanu Purohit. I have been serving as an assistant professor in the Department of Physics, University of Chittagong. And the time we passes through is about pandemic. This is actually COVID pandemic. And I talk and research on dosimetry in small field. So in this pandemic period, we face some difficulties. So, for chalk duster, we miss our chalk duster, and we miss our classroom. We miss our students. But a fortune that comes to us is uh, some media, some online media such as Zoom, such Streamer, that connects us from all over the world. So, organizers request us to say something about my university. Here is the some glimpse of my university. Here you see several faculties. At first, Faculty of Arts and Humanities. This is our new building, and this is our old building, and this is our biological science faculty. And I am in here. If you see my cursor, you see the greenish building. This is actually Faculty of Science. Actually, I belong in this faculty. Our physics department is the prominent department which is established in 1968. We celebrate 50 years in the 50 years of celebration last year. And this is our entrance gate of University of Chittagong. And you see, this is our library room, and this is our museum, and this is our Shohid Minar, and this is Sriti Chottor for the our martyrs of the liberation war. So at a glance, if you see our University of Chittagong, it is actually the second largest university of Bangladesh, across the area of 1,754 acres, about 10 faculties with 54 departments. Around 30,000 students are enjoyed their class in here, and total number of faculty members are 900, around 900, and non-academic staffs are around 2,000. We have a rich museum. Here you see archaeology, sculpture, folklore, and contemporary art. All are located there. And main attraction of our university is about shuttle train. Shuttle train is a part of our heritage. It's not only a transportation facility, but also a center of recreation for students. A bunch of students makes the journey cheerful with their melodious song. So this is a heritage of our university, traditional part of our university. About 3,50,000 volumes of ebooks, 40,000 ebooks, and journals for different faculty centers and institutes make it more enriched our central library. And you see, we our prestigious award, such as many of our faculty members, all of you know, Dr. Mohammad Yunus, awarded Nobel Prize, and Dr. Bikran Prasad Barua from the Department of Physics awarded as Ekushe Padak, and our now Vice Chancellor, Dr. Shirin Akhtar, awarded as Bangla Academy Award and other award in national and international platform. And last but not the least, Professor Dr. Jamal Nazrul Islam also belongs to this university and the Department of Physics also. So this is, and if you see our healthcare system, we have a central medical center here for each university employee and student in precision healthcare, 24/7 services of medicine, physiotherapy, rehabilitation, and psychological counseling. So overall overview, University of Chittagong is devoted to excellence in teaching, learning, and research to ensure creative endeavor for reaching a global height in higher education. So the course is offered in Department of Physics in University of Chittagong, BSc Honors, MS, MPhil, and last but not the least, a PhD degree. We have advanced courses in PhD, such as nuclear and high energy particle physics, electronics and semiconductor devices, material science, atomic and molecular and optical physics, astrophysics and cosmology, atmospheric physics, renewable energy, and superconductivity, and last but not the least, medical and health physics. I will belong this part, medical and health physics. And our research collaboration with, all of you know, the Jamal Nazrul Islam, Professor Dr. Jamal Nazrul Islam is highly collaborated our university with International Center of Theoretical Physics, ICTP, Italy, and Professor Dr. Mainul Haq Miyazi of Department of Physics, research collaborated with CERN, Switzerland, and also IFN, Italy, Institute of Physics, UK, and Bangladesh Council of Science and Industrial Research, BCSR, and Bangladesh Atomic Energy Commission. All of our faculty members, profile of faculty members are given there. You can visit this website, and around 100 papers are published the last 2 years. You can see this publication throughout this website. And this is our image gallery of our some view of our department. You see our faculty, all of the professors, and they are listening some seminars. And this is our 50-year celebration program. And you see teachers take classes on the classroom when there was no pandemic. And you see our practical room and some cultural activities also there. So before pandemic, the situation was like that, and after pandemic, everything will be empty. You see, our central room is waiting for our students, both national and international, and this is about my university. Now, we select some random ideas about COVID pandemic. All of you know, we are trying to treat patient with radiation, COVID patient with radiation. So there are some difficulties around arises when we treat patient through radiation. Actually, we treat cancer patients, tumor growth patients with radiation, external and both internal radiotherapy. But now, nowadays, we are thinking about how to treat viral patients with radiotherapy. Is it possible or not? So some random ideas. First of all, if you think about radiation, you see, this is come from sun. And that is two sectors actually, non-ionizing and ionizing radiation. If you think about non-ionizing radiation, you see our visible light, infrared, microwave, radio wave. This is actually non-ionizing radiation. And if you think about ionizing radiation, they are both having particle and electromagnetic waves. All of you know. Ultraviolet to gamma rays, this is wave-like ionizing radiation, and alpha particles, beta particles, and neutrons are particle-like ionizing radiation. So, why we detect radiation? For environmental safety, personal prediction of occupational workers who are working on radiation area, such as radioactive sources where we use radioactive frequently, and calibration of radioactive isotopes, power regulation in nuclear reactors, research application, and estimation of radiation dose in treatment patient, and many more. So we need to detect radiation. But how? We use different types of radiation detectors, such as gas flow detectors, scintillation detectors, semiconductor detectors, gas field radiation detectors such as alpha, beta, gamma, neutron detectors, and many more. And GM counters are very popular gas field radiation detectors. All of you know about it. So we detect radiation. And the physics between the electromagnetic interaction of electromagnetic radiation of matter with matter, I categorize 4 categories only. First of all, photoelectric absorption and quantum scattering, pair production, and relay scattering. In relay scattering, they only scatter radiation we found, but not energy change. And the basic of this physics, I think all of you know. And in classical scattering, you see incident radiation. I imposed here only X-ray because I talk too much about X-ray. So you see an incident X-ray interact with a classical atom and such as scatter radiation. But when energy is increased, then you see quantum scattering is offered. And if you energize very high energy photon, then secondary quantum interaction also occur. So if you use radiation for viral treatment such as COVID, is it possible or drawback or something? So when we think about the using of radiation for viral treatment, we need to recall some pre lecture, pre literature. So because all of us, all of the physicists are the student of nature. Nature treats us everything. So if we think uses of radiation on viral patient, Oppenheimer more than 50 years ago concluded that Ronjan therapy for viral pneumonia is mainly useful in the earliest days of the disease. So okay, so we can use, but it has some drawbacks, because when we use low dose in chest radiotherapy, it's effective for patients for the primary stage, but we cannot know the later stage. In addition, due to lack of adequate control group in this case of series, it's unclear. So Oppenheimer finally wrote, he actually works on 56 patients, and he wrote, of course, it cannot be proved that 56 patients in series would not recover so quickly without Ronjan treatment. So this is, and there are some risks that is associated with low dose therapy. If we use low dose in COVID-19 patient, we see 0.5 to 1 gray of total chest radiotherapy has a very low risk for COVID-19 patient. That was concluded there, Kirby, at the year of 2020. Although it is conceivable that low dose radiotherapy can improve inflammation to benefit COVID patient, but it has some drawback. What is this? This is it's likely to kill B and T cells. I don't know, actually everyone know about B and T cell. This is a protein cell, and when you use low dose, it kills protein cells. First of all, we think about it. No basic understanding is needed for now. So if this low dose kills B and T cells, and this happens, which may increase the mortality rate of COVID-19 patient. So we cannot use so excessively this type of radiation. When treating cancer, we usually do not consider about the risks, radiation risks about 0.5 to 1 grade for treating cancer or tumor. But in this COVID patient, in the sense of COVID patient, we need to consider about it. So we need good oncologist, good treatment plans with proper chamber for using this type of radiation for COVID patients. Now we go through some radiation therapy, conventional radiation therapy. All of you know there are two types of radiation therapy. First of all, external beam radiotherapy, and number two is brachytherapy. You see a patient take X-ray from a linear accelerator, radiolinear accelerator. You know, external beam radiotherapy is a method for delivering high energy X-ray or gamma to treat patient's tumor. In this technique, radiations are generated outside the patients and targeted at the tumor site. External beam radiotherapy is moreover used in the patient with advanced cancer or cancer that has metastasized, such as breast cancer, lung cancer, colorectal cancer, etc. And in the sense of brachytherapy, we places radioactive sources inside the patient to kill cancer cells and shrink tumors. This allows the physician to use high total dose of radiation to treat a smaller cancer lesions in less amount of time, such as prostate, cervix, head and neck, and skin, etc. Nowadays, about 60% cancer patients are prescribed for radiation therapy in conjunction with surgery and chemotherapy. But you see, the final outcome of radiation therapy, when you use treatment planning system calculation, which should not be exceed plus minus 5% prescribed dose, including all types of uncertainty. It is prescribed for only radiation therapy for cancer or tumor cell. But what will happen if we use this type of therapy for COVID patient or viral patient? So we need to think about that. So if we think about radiation therapy, we must ensure quality assurance. What is the quality assurance? Quality assurance controls defines all the procedures that ensure the accuracy of medical prescription and secure prescription related fulfillment of the therapy. We actually main aims of this radiation therapy is to kill cancer cell or unusual cells and save our healthy cells. So quality assurance measures the following objectives. What type of objectives? Reduction of all uncertainties. You see, plus minus 5% uncertainty bar. So if we use this type of radiation therapy for viral patient, you need to think about proper dosimetry, proper treatment planning, proper equipment, proper treatment delivery, disease, and reduction of likelihood of accidents, that is more occurrence or errors occurring, providing reliable comparison of results among different radiotherapy centers. So we need to think about that. So if we think about dosimetry, measuring the appropriate dose for appropriate cancer cell or tumor cell or COVID patients. If we think about proper dosimetry, so dosimetry is the measurement of ionizing radiation in a given place or person. Its purpose is to provide an estimation of quantities such as the equivalent dose or effective dose resulting from the exposure during a certain amount of time. This is two types of dosimetry. First of all, reference dosimetry, and number two, relative dosimetry. You see a picture of reference dosimetry where you used only cobalt-60 source, and this is the length of 100 centimeter, and the field size. This is called field size, about 10 into 10 centimeter field size, and all are referenced. So this is called reference dosimetry. But if we change any types of condition here, such as cobalt-60 transfer into X-ray or another source, then it is called relative dosimetry. And if you change the field size, that is so occur when you use a small field dosimetry. My topics is related to this center. The field size are not enough standard, such as 10 into 10 centimeter scale field size. We use several types of field size, such 1 to 10 centimeter, 2 into a square field size, another field size, small field size, irregular field size, so on. For both IMRT, intensity modulated radiotherapy, IGRT, image guided radiotherapy, volumetric arc radiotherapy, so occurrence we used a small field size that is not standard. So we need to maintain proper relative dosimetry. And this type of technique nowadays we prefer to use in COVID patients also, but we have lots of hindrance for that. I describe it later. Now you see a reference protocol which is offered International Atomic Energy Agency, a TRS 390 dosimetry protocol. You see first of all of you, most of them are not familiar with blue phantom, water phantom. Why you used water phantom? Because if we consider our body without bone, about 90% of our body is actually consists of water. So if we take about proper dosimetry technique, we need to maintain blue phantom. I give a picture later. And our chamber type is cylindrical. I talk about this ionization chamber in my past slides. And measurement depth is there, and a reference chamber axis, and SSD, source to surface distance 100 centimeter, field size will be 10 into 10 centimeter, what I said before. And this is some equation for the reference dosimetry measurement. I think most of you does not understand about it, but forget it. We need to think about physics and what is arises and how we solve the problems using this type of radiation, which we practiced for cancer, tumor. Is it available? Is it used for COVID patient? our thinking is that. So we forget about it. How this equation is not mandatory. So now we go through a small field radiotherapy in external beam radiotherapy. A small field, dosimetry in a small field. Why you used a small field? You see, if you use thorax irradiated, our thorax is irradiated with some radiotherapy technique, we need to use small field. If we used very small lesion cancer, we used frequently small field radiotherapy. So a small field radiotherapy is very important for frequent using, but we still now we do not have proper protocol. So the conventional radiotherapy of in the linear accelerator, radiation fields are characterized between 4 centimeter to 4 centimeter to 25 centimeter to 25 centimeter scale. Measurement of absorbed dosed water for photon erection above 4 to 4 centimeter fields are established, and several protocols are also given. But when the field size is less than 4 into 4 centimeter, where this theory, Bragg-Gray cavity theory, does not exist. So what do you mean by Bragg-Gray cavity theory? This is a popular theory for measurement of ionizing radiation. This is actually, in simplest, if I say, if you put a ionization chamber in a radiation source, if the existence of the chamber does not disturb the total environment of the cavity, then we say that this chamber maintains the Bragg-Gray cavity theory. This is the perfect definition of Bragg-Gray cavity theory. But when the field size are less than 4 centimeter, then most of the chambers does not maintain that type of theory. So this is the one very large hindrance for measuring appropriate dose in a small field, you see. And some difficulties. So we see some difficulties. First of all, during a small field dosimetry, we do not have proper protocol. And this is the main reason. And some of the machine does not maintain it. And when we use small field dosimetry, small field sizes are not properly standardized. So this is another terms of difficulties. And it is difficult, it is a challenging task to measure proper dose with proper chamber in a small field dosimetry. Why? Because the volume averaging effect of ionization chamber. You know about something about ionization chamber? What is this? GM counter is also a ionization chamber. So think about that. So there is a volume averaging effect when we use small field for measuring dose in a small field dosimetry. And now this results in the underestimation of dose. What do you measure? You find very underestimated dose in center of the field during the reference dosimetry. Number two, big cloud of penumbra. Well, I define both of the terms in my next slides. And big cloud of penumbra is occurred when we used a reference chamber into a small field dosimetry. And number two, focal spot difficulties. Focal spot means we see our reference dosimetry protocol. You see, we use only the ionization chamber. They maintain only ionization chamber for dosimetry purpose. But when we use a reference ionization chamber into less than 4 to 4 centimeter field sizes, most of the time chambers does not detect central focal point very clearly because of volume averaging effect. So this is the difficulties. And source occlusion effect also there. So if we go through the next slide, now you see this is our reference field, 10 into 10 centimeter field, and a reference chamber. When the dose are measured, you see a complete profile of isodose here. The central isodose is high, but when this field size is decreases into less than 4 to 4 centimeter, you see when this reference chamber measured isodose, then isodose is become lower. And when this and narrower to narrower, and then you see isodose very low in the central point. And penumbral region, this is called penumbral region are getting broadened. So what should we do? How we measure proper dose in this type of radiation technique? And if you see source occlusion effect, what I mentioned earlier, you see when the field size are 10 to 10 centimeter, then full output was found. But when the field size is narrower, then penumbral region are broadened, and some overlapping of the dose in the penumbral region was found. So you see, then many publication was published nowadays in the detectors, choice of suitable detectors of small field dosimetry, and manufacture lots of detectors in a small field dosimetry. The fundamental dosimetric properties are determined in view of specific application to dose verification in multiple planes or curved surface inside the phantom. You see in my past slide, you see this is the region. So we need to maintain proper chamber to find out the proper dose in a small field. Because of uniqueness of new thin film sensor consist in their mechanical properties, low power operation, low cost. This is all. And when we think about our protocol, you see, TRS 398 protocol they did not have another lots of correction factor terms in their terminology. But when they updated that in fifth area, summarizes for small field condition and procedure prescribed within the code of practice, they said the strategies what they declared to determine in the information about TRS 483 protocol. And you will be happy to know that as one of my work where I used measured some correction factor, this correction factors was also included in this protocol also. So I show it later. And some hindrance of radiation application of small field dosimetry. I talked it past, and you see the little areas are moreover and overutilized for radiation technique nowadays. So as little section in intensity modulated radiotherapy, actually there are two types of radiation therapy techniques for popularly nowadays used frequently. Small field dosimetry. Number one, intensity modulated radiotherapy, and number two, image guided radiotherapy. What is the difference between them? In intensity modulated radiotherapy, both the chamber and the patient rotated simultaneously when absorbing dose. But in image guided radiotherapy, the chamber and patient's course was fixed, but linear accelerator is rotated. So this is the difference between them. But both of them use irregular field sizes, irregular square, oval shape, and many types of many types of field sizes, as you know. And this is all included small field dosimetry. In any case, the application of little areas for radiation therapy for lungs makes the dosage calculation and arranging wrong due to the presence of electronic disequilibrium, because most of the reverse chamber does not maintain this type of equilibrium, Bagley cavity theory. So measurement calculations are not actually correct. So the current audit involves to the assembly data in respect and centers on the current advances and holding issues related with this sort of photon pillars. And if we think about the dosimeters that was used in small field dosimetry, The major conclusion is that nowadays we used some diode chambers, MOSFET chambers, which field size is very narrow. Our in terms of effectability, diode and MOSFET in terms of determination of films, and we used ionization chamber, MOSFET chamber, diode chamber, as well as sometimes we used water equivalency gels for small field dosimetry for measuring correct doses. This is actually a picture of which I used in my lab, medical linear accelerator, and this is the blue phantom. You see, the full of water actually, a blue phantom, 3D blue phantom, and this is the picture of the internal construction of this linear accelerator. And if I go through this chamber, the Farmer chamber, this is known as Farmer chamber. This is the reference field size chamber, but all other chambers are not reference field size chamber, because this is rather is a diode chamber, and CC01 is a very small feature chamber, and this is also another reference field size diode chamber, and CC13 is actually intermediate size chamber. So this is all about IBA chambers. There is also another company chambers also, but in our lab we afford these chambers for measuring those. So if we think about percentage of depth dose for 10 into 10 centimeter field sizes for both 6 and 15 MB photon beams that was delivered by our linear accelerator, Baryon linear accelerator, you see for 6 MB photon, the peak is sharp. But when the 15 MB, there is the scatter of those. And you all know about that. When the field sizes are narrower, for high energy beam, scattered more doses. So in that sense, for stability condition, we choose 6 MB photon beam for our patients for using small field dosimetry. And we measured our output factor. What is the output factor? Output factor means the performance of the chamber. Performance of the chamber when the field sizes are going to be narrow. So we see this razor chamber measuring more doses than Farmer chamber. And if we match our work, one of the main term of the quality assurance that was I mentioned earlier, you'll all know that we need to maintain a good type of chamber, good size of chamber, and proper technique, and matches our work with previous published work. So we matches our work with previous published work. And next we see with the percentage of output factor for relative doses, and our work is better than previous published work. You look at it, and you see some correction factor that was I mentioned. I measured some correction factor using this type of using razor chamber, actually a diode chamber for relative dosimetry, and I found some correction factors like that, and I fit with a 5th degree of freedom, and my correction factor for 2 and 3 and 4 into centimeter field sizes are completely matched with TRS 480 protocol. That is a good published paper of mine. And if we think about cross-line profile, you see sharp cross-line profile was found for razor chamber. You see razor chamber found a fine cross-line rather than two others chamber. You found it, and this is a very good outcome, and our estimation of those was not found in penumbral region for razor chamber, and reservoir maintain their good quality uh, for 1 to 1 centimeter to 4 to 4 centimeter fill sizes. You see about that, comparing three types of chamber. So we can choose reservoir chamber for for the measurement of relative dose in only for coastline profile because of their performance. So a choice of chamber is maintained for coastline profile, and we use this type our treatment plan to 35 patients of different ages in our medical center, and you found that only for chest for let's find female and chest for female at you see chest for female at the age of 32, the risk factor is not good enough. So our treatment plan is not actually properly used for only two cases, but all other cases it is well fitted, and this is also published. And finally, if I concluded my overall scenario, so as if we use the radiation therapy in small irradiated fields, not only for IMRT, IGRT, cancer therapy patients or the tumor patient, but also if we used this type of technique for COVID patient, and if we maintain the total dosimetry, maintain complete dosimetry technique for a small field relative dosimetry, we found that resort chamber yeah, is completely have a good acceptable doses for penumbral region. But if we think about percentage of depth dose measuring this type of resort chamber, it is not good enough because accumulation of doses are found. You see in my PDD curve. So we found that some uncertainties we can minimize in this technique. How? If we calibrate our chamber with medical linear accelerator rather than cobalt beam. If we change this type of cobalt beam into the medical linear accelerator and calibrate our chambers through it, then some uncertainties will be minimized. And this is all the references that are used throughout my presentation. And this is all my published papers on a small field dosimetry. And thank you.
Thank you, sir, for your very good presentations. And I am also, as I am not in a nuclear physics specialist, so I have some few questions. And another
Okay.
question is there. What type of sources are you using basically? Sources.
Actually, photon sources are used. X-ray beam we are used. 6 MB, 15 MB beam used, and some other cases our medical linear accelerator delivered to 422 mega electron volt sources. But
Sources.
this is the very important thing. You find that when we measured small field and we used in our if we try to use in COVID patient, viral infected patient, you found that that this is not reliable because of we do not have proper treatment planning, total good type of chambers, and some type of protocols. Well, we have lack of protocols, but nowadays most of them thinking about the heavy ion accelerator. And last day I found topics on your in this e-conference that Professor Jobra used in Russia University. He used heavy ion. That's so. This is the technique. So for finding
Yes.
central high central PDD for effective dose.
And
measuring
what
those.
about safety? What about safety measure? Means doing something nuclear experiment, you need a lot of safety measure. As I know, not so many university include their nuclear physics as a curriculum. So because of one word is that safety. We also in the time of doing MSc, no, our teachers say don't use this, so don't touch this type of things. So we are also have not find any uh, practical experience handling the nuclear sources. So what type of actually what type of safety measure you have taken in your labs so to make.
Actually, we used this type of medical linear accelerator in our underground of in
Mm,
our medical center, and all sources, radioactive sources, are kept in a lab, in between
yes,
lab
yes.
chamber, yeah,
Mhm,
and
mhm,
all types of and our chambers, our
mhm.
linear accelerator, all are properly guided by International Atomic Energy Agency, and
Yes.
also
Mhm,
GmbH of Germany, who provided
mhm.
us this type of linear
Technical
accelerator.
support. Yes,
They
yes.
give us actually the technical support.
Technical support. So now one questions I will show you. One of our participant asks, very please read it. Very nice word. Detection of radiation exposure
Exposure
is important
is important for
for.
workers' prone health effects due to radiation. Developing a highly
Mm,
sensitive dosimeters will help in solving the problem. Actually, when we think about our small field,
mm,
as I mentioned, when you used a
mm,
small field, very small field, here I used only 1 to 1 centimeter field. That's what we actually afford. But
mm,
less than 1 to 1 centimeter field size also frequently used in international world. Even if Chennai, you know
mm,
about Chennai Apollo
mm,
Hospital, they
mm,
use less than 1 to 1 centimeter field sizes. So when you used 1 to 1 centimeter field sizes with high energy beam, uh,
mm,
high energy beam has some problems when you use it in health issues. They accelerated from the when from the beclouding of penumbral region, and
mm,
they accelerated doses into healthy tissue and destroy healthy
mm.
tissue. This is the main,
Yes.
there's a problem of maintenance.
Mm,
So if we
mm,
use a razor chamber, I found razor chamber is good, but it's not best, because
yes.
if you use razor chamber frequently, they measure overestimation of dose. Yeah, all of you know, yeah, if you material science, you know about
Mm,
it.
mm, mm,
Diode chamber sometimes measure overestimation of dose, because they losses of ions and aggregate ions, and so on. So ionization chamber is reference chamber. But when we supplement ionization chamber to high sensitivity radiation resort chamber, it's good in some sense, but not all sense, because
yes.
very frequently you measure overestimation dose, which will not helpful for your treatment planning system. This is the reason, actually.
Okay, thank you, sir. For time bound, we cannot proceed on further questions. So, hope you will see you again and physically visit India and particularly Tripura, because we are not far away from your university. And I am also viewing your university and the shuttle train. I am also delighted
Right.
that this type of things are there. And Chittagong is one of the beautiful place in I think Bangladesh. Also, I
Yeah.
didn't never visited there in Bangladesh
Okay.
actually. So I think it's a coastal area. Yes, there,
Yeah.
and so many people in Tripura also from the Chittagong district migrated from partitions. They comes to
Yeah.
Tripura. Yes,
Tripura. Yeah.
so
Agartala.
yes. Yes, yes. So many people are from in Tripura also. We find from this Chittagong district, and where I'm also working is also we find so many people are from Chittagong districts,
Yeah.
and
Yeah.
they are Bengali accent. We understand basically they are from Chittagong.
The
So
Chittagong. Yeah.
very beautiful, beautiful place. So you visit our state Tripura is a very small state in India. However, it is you will find many things in Tripura and visit our Tripura University also. We have a central university here, so you visit here and also to our colleges. Hope we will see you after the pandemic. That pandemic's over, all are we are confined within room. So thank you again and hope
Thank you.
you we will see again in futures.
Okay.
Uh,
Thank you.
Thank
May I
you.
leave?
Yes, yes,
May-
yes. Yes, yes. Yes, yes. Okay, dear participants, we are today we are going to our third session. Start our third speaker uh, lectures. So our today's third speaker is Dr. Bijan Dev. I'm delighted to introduce you, Dr. Bijan Dev, because he is my direct student. So I am happy to introduce him with the audience. So, Dr. Bijan Dev did his MSc from Jadavpur University in the year 2007 and PhD from Indian Association of Cultivation Science, popularly known as ISCS, Kolkata. And his research field is solid state ionics, ion dynamic dynamimetry in disorder material dynamimetry. Sorry, he published research. 15 numbers of research publication in different journals. He has 10 years of teaching experience. Currently, he's an HOD in physics department of RK Mohammed Koilashwar, where I worked at 8 years. So I welcome Dr. Bijan Dev, and this virtual platforms is yours now.
Thank you, sir.
Thank you.
So I at first thanks the convener also of this program for giving me an opportunity to present something. So my theme will be very general. So I will be sharing my presentation now. Is it visible,
Yes, yes, visible.
sir? The presentation.
Yes, yes, visible.
Okay, so my topic of presentation is very general, and here I will only show few slides, and it is a general overview. And many of us already is acquainted with this topic. It is related to the our theme of our conference. So my topic of presentation will be online education in this COVID-19 pandemic scenario. So how online education developed and what is our future. So this is completely from mainly mostly from Indian perspective and from rural perspective. So this is a very basic presentation. So just general overview. So myself, Dr. Bijan Dev. So I am assistant professor and also in charge of the Department of Physics of Ramakrishna Mahavidyalaya. So first, this is a flow of my presentation. So most of the slides will be on summary type, and this will be just overview type. So first, I will discuss on the online education in pre-COVID scenario. Then I'll move to online education during pandemic situation, which we all have experienced, and what will be the future of online education, what might be the future in post-COVID scenario, a general perspective from my point of view. And here I will discuss some online education tool. Many are acquainted with those tools also, but here I will just put a summary of some software and e-learning tools and some content sharing. And then I'll have summarized some issues, challenges, and opportunities with the online education. So first, online education, a basic introduction from mainly from Indians perspective or rural area perspective. So we have seen history has shown us that every crisis comes with a hidden opportunity. Whenever there is some sort of crisis, either medical, technical, or any field, scientific, so it comes with a hidden opportunity like some new innovation, new technology, new discovery happened every time. Mostly in the medical field, whenever some crisis, some pandemic happens, some new something innovative has come to us for betterment of the society. So this the present pandemic situation, the COVID-19 pandemic situation has shown us that current way of life that we are living does not work. We have to change our way of life, and what we perceived earlier as normal is not normal. We are moving to a new normal. So the evident the most important thing that we need to change, or the sector which needed change, is the education sector due to this COVID-19 pandemic. So earlier what happened, we used to say that literate are those who can read and write, but 21st century we will be calling the literate are those who can learn, unlearn, and relearn. Here we will learn new things, we will unlearn old methodology and techniques, and we will relearn again new methodology and techniques. So here in this COVID pandemic has shown us something new, not new, but some innovative and advancement in online education. So this will cover many parts like digital education, e-learning, e-content, virtual classrooms, ICT enabled teaching learning, etc. So obviously online education sector has been mainly affected or mostly affected directly as a part of COVID-19 pandemic. So what was our situation in the pre-COVID scenario, say a few years back? So from India perspective, if we see, we already have existing open learning system, so which facilitates anyone to learn anywhere to learn at any time as per convenience. So what are the facility that we already have are like say distance education. Distance education mode study we already have already existing for this decade. So in distance education system, what we have it many universities and many centers have adopted. So learning from distance mode from home, like say correspondence course, mostly some remote places students, young students are given opportunity. Those who are unable to attend directly the regular traditional form of classes, they can do in distance mode. One example that we already have are the igno that is a national university of India that provides a wide variety of distance mode study. Another is e-learning is already there, but it is basically in the form of flipped learning, means as an additional source, and it was a choice. So student can learn many things online additionally beyond the traditional classroom, and this was mainly restricted, or you can say as a, generally these are being provided from for the institution which are well developed and developed region, mainly urban region. So many private institute and top level government institute, they provided this e-learning, e-content as a additional teaching learning to the formal traditional education. The remote areas, remote places education were still in the form of traditional face-to-face learning, because infrastructure was not developed in such a way in the remote places or in many places of India. So digital education, it was growing at a speed of say 40 to 50% in last 5 to 10 years. So during pandemic, this online education has got a boost. Obviously, every classes, everything, university, everything are shut down. Everything was shut down. So the normal education system changes to online education system. So here we are taking virtual classes. Also the industry are shut down, so their work from home concept was developed. Earlier it was there, but in a limited uh, situation and mostly in developed countries. But in developing countries like India, the infrastructure was not such in developing at such a phase to make it completely online, or the students were not motivated much, also the teachers. But this pandemic, COVID-19 pandemic, has forced us in many ways to move to online platform. So online education got a boost during COVID-19 pandemic. So digital technology and new innovations were also continually developed to cater to the need of online teaching and learning. This online education cannot run without digital technology, digital transformation, digital infrastructure, that is ICT infrastructure. So like say 3D animation, artificial intelligence, interactive audio visual classrooms are must for this digital tech online learning. So this got a boost and new innovative methods are developed, like say already for past already like Byju's, Academy, they has developed many interactive system of classroom in this pandemic situation. Now, another is digital literacy. It has enhanced to a greater extent during this pandemic. Earlier pandemic, many people, students, and also parents, guardian, many were not acquainted with digital systems or digital content. But this pandemic has forced everyone, even parents, teachers, students, everyone, those who have not used, they have learned at least something new using, like say, mobile technology, desktop technology, or internet, social media, many things they have learned. So enhancement of digital literacy was there. So it has a benefit that we can now transmit education quickly to remote part also, where there is availability of digital connectivity. Now, so these are the situation of pre and during. So during online education got a boost. There are many innovative technologies are coming out, many learning techniques are coming out. There is enhancement of digital literacy and proliferation of digital information among rural and as well as urban. Urban was there already, but rural sector also got benefit of this online transformation. Now we move to the post COVID-19 situation. So what might happen in the post COVID? We can guess only, but these are general guessing, and everyone can understand what might happen because we are already experiencing the during situation. So what would happen in the post COVID? We very well know, and we can guess it. We can predict it. So there will be ICT integration with the education system. ICT will be must. It will be part of the learning system. So we will have e-learning system. There will be technology blended learning. So blended learning will be there. Earlier there was flipped learning. So additional resource, student can opt, they can learn, they can boost their knowledge, they can prepare better by seeing additional video materials. But now what COVID-19 has forced us to make it technology blending. So the normal formal education system, a part will be mandatorily technology based. So digital learning will be a new normal. So another things will be the edutech sector industry, the educational industry, educational technology industry will get a boost. So in the next 5 years, it is expected to rise about 21% CAGR. That is a huge, around 5 to 7 times it will rise from the 2020 years. So there will be huge boost in the industrial sector also. The technology, educational, education based, technology based educational industry. So it will increase the chances of employment, employability, etc. So there will be blending of technology, ICT tool in as a part of our normal curriculum. So most of the growth of educational technology industry will be by the content. So how well the content is, how attractive the content is, how genuine the content is. So there will be increase in innovation in the content. And the main key driver, as we can guess, will be the proliferation or penetration of the internet and smartphone. And for the past few years, this penetration of smartphone and low cost internet has helped in enhancement of this digital proliferation, so that we at least we can cope up with this pending situation. Otherwise we would be in a total mess, in a trouble for this concerning the education sector. So for past few years, India digital initiative was very well structured and it was growing. So it helped in coping up with pandemic situation. It is helping, not to the fullest, but at least it is helping. So there will be boom in the ICT sector, there will be technology blended learning, and there will be, obviously this will lead to increase in the industry of the education tech. Now, so there will be blended learning. So what will happen? So university and colleges, there will be face-to-face delivery, and also e-learning content will be there, which will be fused with the for normal curriculum. There will be increase or enhancement or innovation in the learning management system, which we call LMS. So this is a complete management system for entire institute, where entire curricula, say exam, evaluation, assignment, and classes of entire institute can be monitored and customized as per need of the institution. So most of the things can be done online. So there will be obviously improvement in learning material. So because student and teacher, they can get material from worldwide, digital material, digital content from foreign universities. Student can learn from anywhere where he likes. So there will be competition for quality. So those institute or those teacher who can provide better material, student will be more engaged to that them. And another important is rise in the collaborative work. Obviously, collaboration will increase because online we can collaborate from foreign institute without physically being present. So these we have already experienced and are experiencing in this COVID situation, that we can share the expertise of other faculties, experienced faculties of various institute. We can share study material. We can collect study material from other institute, and so this is so there will be rise in collaborative work in research as well as in teaching learning. Now, these are some of the educational tool, or everyone many knows, a few may not, but these are very well known. We are using in this pandemic situation. So some of the free, I will be discussing just some video lecture or live classes, apps or software that you can use freely or paid for meeting conference like this. So Google Meet, we know many students, our student we used to take classes in Google Meet, that is part of G Suite. So this is mainly video meeting conference app. So this is a very good app where we can take live classes. So but there we have limitation of 100 participant, and time limit is there. Similarly, Zoom meeting, we know Zoom was very well received when it was launched, but it has very limitation of time and participants. But video and audio quality is very good, and it easy of use. It is very easy to use. And then StreamYard we are already using for this conference. So this is mainly video streaming app. So from StreamYard, live participants are very restricted, but we can stream it to other social media platform like Facebook or YouTube, so that unlimited numbers or greater audience can view the live meeting or conference or like that. So this is not suitable for class, interactive class, but mostly for streaming conference, webinar like that. So Google Meet and Zoom meeting, they are very well received. Now there are limitation of time, participant, video audio quality, and bandwidth, and also security issue is the most important. So paid version is also there. Those are much better compared to the free version. Obviously, the Zoom meeting paid version is the best. It has secured SSL features, bandwidth is very high, or we can opt as per our package of institute package or individual package. Streaming features are there, and very important and innovative things were there. Breakout rooms, that is group discussion rooms, were there in the Zoom meeting. So they are around say 200, 300 or 100 participants, and unlimited meetings, unlimited time. These are their features. Then we have Microsoft Team, that is offered by Microsoft. It has excellent collaborative features because it integrates with MS Office, Word, PowerPoint, Excel. Then we have another very important this GoToMeeting. This software was used earlier, but now Zoom Meeting and Microsoft Team taken over that position. So GoToMeeting is excellent software for video meeting, live conference like that. It has very well security features, and bandwidth is very good. Also, price is comparable to Zoom. So these pricing are around say 10 to 15,000 per year. So this drawback is that price is little bit higher compared to in our remote area or rural area, rural institute. Subscription is little bit costly. But anyway, if we want to move to online education, we have to go for paid version, or if we do for free version also we can do, but they are less secured and time limit is there. So this disrupt the normal curricula. So Zoom meeting, Microsoft Team, and GoToMeeting are very well received live meeting conference and software. They both mobile version and web version are also available for these apps. Now these are some of the tools I am saying. Everyone, many teachers are already acquainted. Also students are no students have used these platforms. These are for like some sort of LMS, learning management. So G Suite for education is one of the cheapest LMS system that we can use for our educational institute. Low cost version is available. It has all of the features of Google, that is Google Doc, forms like this. And most important, two parts are there. One is video meeting, that is Google Meet. Paid version is there. So we have increased participant, and live streaming is possible. Another is Google Classroom, that we are teaching to the students. So in classroom we can evaluate exam, assignment, grading, survey, quiz, etc. We do through Google Classroom. We can also share study material in classroom. So G Suite has all the features. So for video meeting we use Google Meet for live classes, and for sharing study material and assignment, grading, all these things we use Google Classroom. So the free version is there, but it has limitation of many features, and paid version, this is low cost features for educational institute, but has restriction that educational email are required, educational institute email are required. Then we can use another app, teachmeet. Many knows, I also personally use this app. So this is a free app, it is available in web version and app version also. Here this Google features, this Google Meet and Google Classroom, these two may be combined. We can think of that these two are combined. So here we have inbuilt video class lecture, recording of that live lecture, and blackboard whiteboard animation system, just like classroom, but we need a digital interactive pen like that. Student attendance, assignment objectives, sharing study material, all these are available. So Google Classroom, Google Meet combined features is there, but they are relatively new, and all full features are not developed, and some error might be there, some bandwidth issues are there. So Google Classroom, Google Meet are existing for many years, but teaching are new, but they are developing. So this is also a free and good app for teachers for teaching. Now here I will share just few of the app that are available for content sharing. So one thing, we are using many apps for online content or e-content, digital content creation, but we have to store it somewhere for easy sharing, so that we can share to the student easily. Student can also access them easily, and it is available 24/7. So some of the easily available online storage or online content sharing platform are like Google Drive. You know, this is a part of Google. We get free 15 GB of data if we sign up with Gmail or Google sign up. It is also part of G Suite. So here it is good for collaboration and sharing, and for student evaluation like this. We can upload all the student data. Data can be stored like quizzes, survey, assignments. All data are stored in the G Drive. So it has limitation of 15 GB, and some security issues are also there because the data are not encrypted. Now another platform is Mega that we know. It offers 20 GB of free storage, and one benefit is that it offer highly secure and encrypted version of data. Another is Indian data center based DigiBox. This is very new. Last year it is launched. It offers 20 GB free and very low cost, 100 GB. So this is Indian startup company. They have started this, and this data center is as per Data Protection Act India. Server are located in India. So this we can, everyone can sign up. We will get free 20 GB. But one issue is slow bandwidth. Speed is little bit slow for upload and download. Now another two popular online storage are pCloud and Ice Drive. They both offer 10 GB free, but they only have lifetime plan. So we can pay once and we can use for lifetime. They have excellent online encryption, online storage, and better file sharing, and bandwidth is relatively good for the paid version. And another is Microsoft OneDrive. This is available with Office 365 subscription. So this is a little bit costlier. So it is available freely with Office or Microsoft Teams or like that. So whatever Microsoft product we purchase, we will get OneDrive, 1 TB storage. Now here I show some of the initiatives that are taken by government of India, mainly through MHRD, Human Resource Development, or Ministry of Education. So this initiative were already taken few years back when there was no COVID situation. So this helped India in some way, also us to for getting online teaching learning, adapting it faster the way we did. So earlier there was already Digital India initiative under which NMEICT platform was there. So through this, all rural and all remote sections, you are connected to high-speed broadband connectivity. So and so many initiatives were there. So some of the initiatives that helped or that were existing and now developed further due to COVID-19 are, I have listed some of these. So these three, the Diksha, ePathshala, and National Repository of Open Educational Resource, these are mainly for school education. So Diksha, NCERT, CBSE 1 to 12, ePathshala, we get a lot of online ebooks, video lecture by experienced teachers. Also, parent can see how their teachers are doing, grading, all these things are available in these platforms. Now, for higher education, there are two very important platforms that were developed. First is the NPTEL. This is a lifesaver for the engineering branch or also for basic sciences, because this NPTEL was almost developed around 10 to 15 years back by IITs and ISCs. And it has largest collection of video materials by world-class teachers from IIT and ISC. This NPTEL also they organize mainly many faculty induction training programs and also mainly engineering courses. So these are very beneficial for the students very much. So this helped in this pandemic situation. So government is further enhancing this NPTEL teaching NPTEL platform. Another was SWAM. SWAM is our national educational platform. So it provides more than around 2000 courses are there for school level, UG and PG. And important thing is it is integrated like some sort of blended with this formal education system. So it will be blended in near future. And now at present, some credit transfer of around 20% is available. So some student, PG students, they can complete a course, and many university are mandating it because as per UGC, it is mandatory to take online one more courses. Another video channels are there for viewing video along the dish TV, and EPG Pashala. This is for postgraduate students. So many platforms are available and many are developed. So many other portal were already existing that I have not mentioned, like Sud Ganga, like PhD thesis, research thesis. So many things, many research oriented platforms are also available from Government of India. So from InclibNet, Digital Library, National Digital Library. So many portals are developed. These are already existing, and but this Swam, PG Patshala, these got boosted during COVID-19 situation as they are somewhere more structured. Earlier, it was not structured. India was not ready for a structured online education system. So now it is more planning are going on for developing structured way so that a curriculum may be completed, means a certain curriculum or certain course can be completed from starting from admission to the evaluation process. Now I move to issue, challenges and future. Obviously we know the main issue, that is the backbone issue with the online digital education, is the internet connectivity. So there is the inequality of availability of resources, obviously. So what is this? This is the internet connectivity, and this internet access is the main that is required to access online class. Many institute and government are mandatory, but if we don't have internet connectivity, everything falls apart. So there are many restrictions like financial, social, and geographical barriers. So these restrict this reaching of these online classes or the benefit of online classes to some sectors, mainly rural sector. As you can see, rural sector internet penetration is 15%, and India major portion of India is rural area, and urban household with internet is around 40%. So there is a digital divide, and this is the main issue. And due to also many financial constraint, many are not able to access the electronic gadgets. So there are two issues. One is the availability of the electronic gadgets or the device that are required, like laptop, mobile, or whatever. At least some electronic device are required, and one is the internet connectivity. Even if many are able to buy or procure electronic gadgets, internet connectivity is an issue in many remote places due to geographical barrier or financial barrier, because data also cost. So obviously these issues, main issues is internet connectivity. If you can provide low cost internet connectivity, then a major portion of our initiative, government initiative to provide online learning or digital learning to every sector of the society will be available. Now, some of the challenges. So one of the challenges that we are also experiencing during online classes is students are less attentive in the online classes because we cannot see direct face-to-face contact is there, eye-to-eye contact is not there. So they are becoming some sort of passive learner. So this is more of a one-sided communication. So I am saying something, the other side person are listening, he may not listen, he may not be attentive. So this is practical problem, and many reports are already out. So it is saying that low attention span and one-sided communication is hampering the traditional, in traditional form of education it was eye-to-eye contact was there, and direct means the received received of the things, the content or understanding is better in traditional form in many cases. Obviously it may not be in all cases, but in most of the cases it is saying that it is mainly for the school level, not for the higher level. For basic level, like say primary level students are now they are sitting in home isolated, they are going for the internet, so they are maybe problem with the attention system. Also, contact hour with mobile and laptop, it is hampering directly our eye and brain, it is hampering our brain also. So health condition also need to be taken care. Another issues, other issues like admission and recruiting students, examination and evaluation. Admissions means students might some institute, the institute now are available to all. So some student who likes another institute, he can take admission of his choice in a distance mode or like mode. So some institution students will be reduced. So many institute depend on the fees and admission of the students. So if he leaves the institute, many institute are shut off. There are reports of like this. So many institute will be shut off. Those cannot afford the online system, so student will move to some other better or privatized or some advanced institute because they will be easily available to them. Examination and evaluation, this is the important factor in case of online, how examination will be taken, how to evaluate whether it is a true evaluation, because for traditional form of education at least we can proctor the examination and we can evaluate, but in case of online this is something partially partially true. This is not exact evaluation. Also, examination objective type he may be doing or how he may doing answering the examination, we don't know. So, examination and evaluation need reforms in case of online education. And another is social and mental. This we already know. When a student goes to college or schools, he interact with other students, other friends. So he developed morally, socially, intellectually. But where now due to COVID pandemic, he is staying at home. So this physical and mental growth is hampered mainly for the young childrens. So online classes shut down this possibility of emotional growth or say physical growth or mental growth or say social matters. So there is a issue with this. So, but still we have opportunity. We have challenges. Obviously, every new things, every crisis has challenges, but we can cope up. This is only 2 years. We are in the COVID-19 pandemic, so we have developed lot of online educational systems in this 1 year, not 2 years, only 1 year. We have moved many things to the online platform. We are just 1 year back or 2 year back, we cannot imagine or we cannot think, at least from our perspective, that we will completely move to online within 1 year. But now we can take classes online. At least students are also acquainted with the digital content or digital learning platform. Teachers are also able to take either by some way directly on the online platform or some other social media platform. I mean, at least one or other we are able to use. So in the next few years, hopefully, we have a lot of opportunity to utilize this online teaching learning platform or online education system or the digital transformation system. So first is we can provide equal access to education for all. If the issue, that is backbone issue, that is the internet can be provided and the infrastructure can be provided, we can increase the gross enrollment ratio. That is one of the initiative the government much earlier, increase the enrollment ratio because many dropouts were there. So if we can provide easy access to education via online mode, many can study from home. So enrollment will increase. At least they will learn something. A student will be interested in enrolling for higher education. So also this online education will help in a flexible and more student-friendly approach of curriculum design, because if you don't attract student, it will be completely failure. So there will be competition for quality content, teaching, learning, and reform in the curriculum system or digital learning. And another is a opportunity is we can develop skill development and enhancement of skill in the digital sector, because in the coming decades, digital skill will be in high demand. So by this using this online technology, the digital technology based skill in engineering, science, and technology can be provided. Training to the interns may be provided through online. So this has been provided by many industries nowadays in this COVID pandemic. So the Atmanirbhar scheme of government, that is developing own skill, manpower, and own Atmanirbhar Bharat, that is the self-reliant. This scheme can be made fruitful by employing this online digital education sector. it will play a vital role. And there are many opportunities, so I am just listing some of these from my perspective. Other is the classes will be mostly non-rigid and it will be flexible, means student can choose their own style of class and his own choice of subjects. And there will be cultural and social diversity, student can learn other institute, other countries culture, social things, many other creative things from online. He can he can subscribe to any other universities courses, any social related courses, cultural courses, so he can learn many things beyond the formal traditional education. So there will be more exposure to the digital technology that I have told just now, that artificial intelligence, machine learning, and augmented reality. This will be the this is next generation technologies, where most employment will be available. So we can develop skill manpower for this digital era. And other things will be, there will be focus on extracurricular and creative activities. Also vocational training can be provided from online for industry related skill. And last one is, there will be a subtle change in the purpose of learning. So what do you say, this earlier just formal education system where they are come to the college or school, take classes, exam, evaluate, like this. Now additional things would be included which were not thought earlier. This pandemic has shown us this, like say adaptability, collaboration, more adaptability to the situation, creativity, and emotional intelligence. These points will be inculcated in the curriculum, because we have seen that these are most important things we required in the learning, mainly in the primary level of schooling. So here I end my presentation. So actually these are very brief overview of what are online education, how it is developing, and what might be the future. So thank you.
Thank you, Vijan, for your elaborate discussion, starting from starting from our past, then to present, and then what will be the opportunity and other things. You rightly said that we are in digital divide society where internet connectivity is a big issue, and this is a problems we are facing. Students are not mm, getting the right bandwidth in a remote places. Or it says India has an average 7 Mbps speed, whereas other country has above 50 or other things. So this is a problem. And another thing I feel from your lecture, that you say structured network, means India is going to be a very structured online education system. UGC is giving importance on this. 50% of the 40%, I think 40%, their recent notification, they say 40% of the curriculum, or 40% of the curriculum they can cover through their online modes. So this is a very good initiative taken by UGC. I think another problem is that the universities exam systems, university is not finding the way how to take the exam uh, for students. They are really in difficult position, that many university is not taking the exam systems, improve their exam systems so that they can take it digitally. The problems is same. The student, all the students are not connected with the good network, so how they can take. uh, and issues are very issues are there. Many limitations are there, but disadvantage can be covered into an advantage. So questions are there, people are asking about what about the practical, what about the how can a student can do a practical through online. It is a, yes, issues are there. So this is how can you highlight the issues, say practical.
Okay, this can be one thing, that may be like a virtual class. So many virtual laboratory based platforms are there now, it is
Yes.
developed from past few years. So there might be that in future, obviously this is an issue, because things that required experiments, like industrial skilling, I am saying here, I have told only about digital skills, that is programming, coding, artificial intelligence, that we can work from home. But for experiment based, like science mainly, and for engineering, that practical that is an issue
Handling.
how we can do. So one thing is that laboratory, like say UG level or school level, first we can approach with the virtual laboratory. So many
Mm.
universities like MET or some other universities are there. They are providing that virtual laboratory where they can really feel the three-dimensional how to do an experiment, how to interactive way of doing some experiment, like say simple harmonic motion or anything like that. So they can change the values input. So like say interactive way. So this is one
Yes.
of the things. And other thing
There,
is that I
mm,
have not mentioned here is like say online platform will be there, blended learning will be there. So student will learn the theoretical part from home or say online version. So
yes.
more time. One
One option.
advantage is that we will get more time for practical or
Mm.
experimental based in the traditional mode. So in traditional mode, there will be mainly discussion and experimental part that need formal system, and 50% part theory they can do from online. So some time we will get more, but how to utilize that time for the experimentation, because experiment they cannot do by just online, they have to do it
Mm.
practically. But that is an issue often
Mm.
till now.
The handling of equipment, viewing the instrument is an important. So for science, we have say 30% in curriculum experiment part, 30%. So they 70% theory is there. So interactions is there, interactions in online classes we have, we adopt main most of us adopt the online classes, but we don't know how to do the practical purpose. Still we have to be in depend on the central systems, because developing virtual lab, many of participants are questioning virtual lab needs something expert in this field, mostly in say programming type, and then to develop this virtual lab we need some more expert in this field. So we are waiting for that uh, already some institutions, Indian funding institutions are coming up for developing this virtual lab. So we are hopeful that upcoming we will learn something from our home, that how to lab going to lab and do the experiments and how to analyze the results. These are good, but pandemic give us many things, give us to opportunity to learn many things, that we are virtually connected from each other. Our initiative also like that, our four colleges are, we unite our four colleges, and so that we learn and come together. So pandemic has sees us many things, but during pandemic we also learn many things. All of us
Yes,
learn
collaboration is the main one of the main.
collaborations, collaboration, connection, digital connections. So these are many things we have learned from pandemic also. So, so I would like to thanks to Dr. Bijande for his presentations. Everybody, I feel everybody understands from this scenario what is the changing the scenario happening throughout the world and India. We also part of it. Do not think that we are all participant. I am just going that we are part of it. We should learn from the through digital media. So do not shy away. We our one appeal to the students is that please connect with us digitally. This platforms we are making, we four of our college make this platform so that we come together, student teachers all we come together, and let's just start new thinking, new process, and new interactions. So thank you Vision again. And there is I think we are going to end our second technical sessions. So second technical sessions we have three speaker. uh, as you know, from very beginning, from we have the speaker like we have the speaker like Shubhrotanu Bhattacharjee, then Shantanu Purohit, and Dr. Vijan Dev. All our lectures are very good, very informative. I find this is a very student oriented, and if you listen it again and again, you will learn many things. So here I want to conclude the technical sessions. Now we are running short of time, so I want to hand over this sessions to next our convener, Dr. Raghunandan Das, and one of our coordinator Sujit Ranjan Das is also waiting in backstage. Our third coordinator Bijan Dev is also waiting. So I want to hand over to them. First, I hand over to our coordinator then our convener Raghunandan, and our uh, coordinator Sri Sujit Nunez. Raghu, please switch on your microphone. Switch on your microphone.
Right. Thank you. We are really grateful with the organizers, really grateful to our invited speaker, right from Bangladesh, from Chittagong University, from Russia University, from Southeastern University of Sri Lanka, from Thailand University, from Karimganj College, from our neighboring college, R.K. Mahavidyalaya. We got six very renowned educationists in their respective fields, in the research and technology field. They enlighten us. Actually, with the organizers requested the invited speaker whether I am audible, Rahul sir.
Yes, 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 yes. You are audible, Raghu. Yes,
Rahul sir,
you're
I am audible
audible.
or not?
Yes, 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 yes. You are audible.
But I think
Some
I
network.
am facing some connectivity issues. Huh? Okay.
Yes, yeah. There
So we
something network
requested
problem is
the
there.
invited speaker to, yeah, to make the presentation in such a way that the presentation should be understandable to our students. Particularly, our target group was students and basically the UG students. We were doing the collaboration work, and in our collaboration work, there are four colleges are there. So in our honors courses, in the general courses, around 1,000 students are there. So basically targeting those 800 to 1,000 students, we frame this program. Along with that, for the PG student, for the research workers, for the faculty members, we designed this program. So I hope what way our invited speaker, what nicely they have presented, so easily they have presented, so nicely presented. So I think most of the content was understandable to the target groups, our
Yes,
students. So in that way, if I could say that our this international conference is fruitful, and particularly from the six invited speaker, we have come to know what is the present educational scenario, what would be the next educational scenario, what is the storage of the battery, how we could enhance the battery, what is the technology is going on, what is the contribution of India. There are so many scientists are there, researchers there. India is contributing a lot also. In the pandemic situations, we have learned so many things. As you see, before the first wave, India were not having the PP kit, were not having the testing kit for the COVID. But during this 1.5 year or so, we have made so many things. Even we are now exporting. During that pandemic period, our researchers did hard work and they have come with two, let's say, some sort of there is opportunities are coming. But if we are able to convert those challenges into opportunities, then surely we will be in the right track. And most of the cases, our invited speakers shown the pave of the way. They have shown the right track, what path should be followed, and navigating those paths, we can progress ourselves. So I hope our target group, the students, researchers, will follow this one. They will navigate, they will nurture the scientific and the research works. If they will be nurturing this properly, then in the near future, surely from us also, we can invent something and that will be helpful for the society, for the nation, as well as for the whole world. So this is very important. So another thing I would like to express my gratitude once again to all the invited speaker, Dr. Monira Jannatul Kubra, Associate Professor, Dr. M.J.M. Jafi from Sri Lanka, Dr. Shantanu Purohit from Bangladesh, Dr. Subratanu Bhattacharya from Kalani University, West Bengal, Dr. Nirmal Kumar Sarkar from Karimganj College, Assam, Dr. Bijan Dev, and he is also one of the coordinator of these sessions also. Another thing, you see, all from all the lectures, it is crystal clear now that collaboration work should be done. We should go for the collaboration work. We should cooperate each other. We can share our views not only with the researchers, not only with the faculty members. We should share our views to our students. Students should share their views with their teachers and others so that we can improve ourselves. We can reach what destination we are intended to reach. So, in that respect, I say, being the convener, what nice through nice considerations we have conducted this seminar, this international conference, and how so many active participants also were there. They participated. They put very relevant question as it is not possible through this platform. Directly we can interact with our target groups, but by putting the questions, by the putting the queries, they interacted with the learned, the invited speaker. So that is also one of the achievement. And we are hoping on the near future we will be doing the collaboration work with our neighboring countries and the renowned institutions in our countries too. So in that respect, we are very happy. I am personally very happy that I think it is a good program and it is. So I am now requesting Shubhrutanu sir, please share few words regarding this international conference. Sir, please, over to you.
Um, yeah, I'm very happy uh, by participating in this venture that is initiated by you among the just to motivate the students from most of them from the undergraduate and postgraduate. So it is a very nice initiative, I feel, and actually this initiative will not only motivate them, but this will give them actually a break from the pandemic and as well as normal study, normal classroom work and others. So it's a very nice initiative. But one thing I should mention means what is actually uh, in my feelings, that if the interaction can be done one to one, then it may be more fruitful. But maybe some constant from your end also was there. That's why you have to use this kind of platform, because to accommodate most of the students, among them you have large participants, etc.
Yes.
But that is the main thing actually I was missing, because I always like to be interact with the students directly, because students are actually the main listeners and they have the queries which are really wonderful, because you know that innocent people's query are really difficult to answer. So that's why they from the innocence they ask many things which actually lot of people don't know, but they don't ever ask actually. So that's why I always want to talk with the students directly, to like answers questions from them directly, and to answer those questions. So that part actually I have missed. So on the other hand, I have seen your YouTube streaming. That was wonderful. and their live chats were there and everything. That was fine. But again, I'm just missing that one that I have already mentioned. So if you can in future, if you can do such type of things that student can interact directly in the end of the talk, like question session or something, that will be much more attractive for students as well, I think. So that is my point of view. So, and other things, your initiative I should appreciate, and from the college end, and I'm very happy that you have initiated such a wonderful system and wonderful conference. Okay, so so that's all from me. Thank you. That's all from
Yes. Thank you, sir. Actually, this is
Yeah.
live interaction is important. Many students ask many funny questions. I also see,
yeah, yeah.
but it's for him. It
But
is very important.
no,
For him,
nothing is funny. Actually, I always like this type of questions. Actually,
yes,
so that's why I never think that student can ask funny questions.
yes,
Because whatever they think they can tell, and
sure, yes,
for us, like we think, okay, this kind of question we should not ask, but they don't think like that. Because when I
yes,
was student, I also
yes,
used to ask many things, and people sometimes become annoyed, but sometimes they answer, and from this
yes,
answer I able to learn anything, many things at that time. So in that way, I think direct interaction is very important in any kind of session, like
mhm,
international conference or any other conference or anything, anywhere. So
mhm,
that part actually I was missing, but it's not in your hand. I understand,
mm,
because this platform actually does not allow this kind of
yes.
interaction.
Only six
Anyway,
persons allowed
yeah, yeah.
in the
So
screen.
anyway, it's very nice experience for me. This is a new system. Always I am learning something from new systems. And once again, I would like to express my sincere thanks to you for inviting me to give some talk in front of you and the students. I hope the students may enriched from my talk or little bit, whatever I tried. So anyway, uh, that's all from my point of view. Thank you.
Thank you.
Thank you, sir. Actually, we are delighted that you are with us. You accepted
Thank
our
you.
invitation. Uh, So really, we are delighted, and so nicely you have presented. I was going through, and I was learning so many things. I learned so many things
Thank, thank
today,
you.
and very interesting. And this is the need of the day, actually, what you are
Yeah.
explaining. And yes, because every person nowadays using mobile, at least they could understand what is the
Yes.
utility of the battery. And
Yes.
if battery is not sustainable, it is not sustaining, then what could be that everybody at least understanding? So research must go. We must that is invent more reliable battery or other devices so that at least it could run 7 days. Initially, when we were using the mobile, very small mobiles were there. Most of Android systems were not there. So at least battery were running for 7 days or more than that.
No, no.
But
You are
nowadays,
missing
not
one
more
thing,
than
sir.
24 hours.
No, no. You are missing one thing, sir. Just I want to interrupt. Actually, at that time, the mobile you are talking about, that mobile was only for calling, and nowadays people use mobile for everything except calling. Okay, I don't know how many people
So I
actually
wish,
call
yeah,
their parents. The students actually, they have smartphones. The parents they provide
actually
smartphones
at that time
because
only voice
son.
call were there. That is why you are
Yeah,
sustaining for the
yes, yes, yes. But nowadays people actually use for everything that I told,
free apps.
for
So
for
they should be also
gaming, some
should
for
sustain for seven
gaming,
days.
video, etc. But minimum time for calling. They don't have time to call their parents, their relatives, their teachers, and everything. Everyone are using WhatsApp. Hello, that's all. I am fine. That's all. So, and they
Yeah,
are
yeah,
using
yeah.
internet, they are using everything which are actually draining the battery. uh, this is the requirement nowadays. And in online system also now the requirement become very very large, because without smartphone you cannot accommodate student in your class, or the student also cannot be entered into any online platform to enrich, or this is now unavoidable system. So everybody should have smartphone or laptop or something like that, so that we can teach them. Or this is the scenario for everywhere nowadays, specifically in this pandemic situation. And in pandemic situation we have understood what is the requirement of this kind of battery system and mobiles, how the batteries are, because earlier people was not bothered about battery. But nowadays, during one calling back-to-back classes, people are seeing that okay, my battery is draining. Why it is happening? Because I have fully charged in the morning with a C-type battery, 26 volt battery, but now only after 2 3 hours it completely discharged. How it is happening? So that's
Exhausted.
why I tried to address this issue to the students, that actually what you are getting in the name of fully charged is actually 30 to 40% less what you should achieve if you don't use C-type chargers. But C-type chargers companies are
Right,
actually
right.
providing, so you
Yes.
cannot you cannot use other chargers actually. So in that way the things are going on.
Yes, yes.
And that is high rate charging also damaging your battery. These are the company policy, that within year your entire battery will be die out, and as you cannot remove it, because now your back cover is completely fixed. So because you are using they are giving you lithium polymer battery, so you cannot detach it from your system, so you have to throw the mobile and you have to purchase
See,
another. So this is the policy. This is the policy of the mobile companies nowadays. Anyway, we are happy with that and we are doing according to that policy.
yeah,
So that's all.
yes, sir. Thank you, sir. Actually, that I would also like to name that research is going on, and people are also trying to come with new inventions, and new
Definitely.
batteries or new other systems will come. Uh,
Yes.
so, thank you, sir. So, I am requesting Dr. Sujit Ranjan Das, sir. Please share few words in the interaction sessions. He was doing a lot for making this event a successful one. He was always encouraging. He is our in charge of our department, HOD in charge. Dr. Das, please share a few words.
Thank you. Uh, Wishing you all a very beautiful time ahead. And at the very beginning, I thank to Dr. Raghunandan Das, the convener of this international event, who works hard throughout. And I am feeling pleasure actually, or to privilege to thank Dr. Rahul Bhattacharya sir for chairing the session by adding so many constructive notes throughout the technical session. And mm, our Rahul sir actually constantly boasting us always to organize such type of events in different fields. And he is actually suggesting us in all directions. I thank you very much. And I am actually reading some reports on the today's deliberations uh, about the first speakers, Dr. Subratanu Bhattacharya sir. He is the Associate Professor, Department of Physics, Kollan University, India, West Bengal. His topic was innovative electrolytes for lithium metal batteries, and he actually explained so many things in details about the lithium metal batteries, about power versus energy, uh, about the capacitors, classification of storage techniques, and how actually we can store energy, low energy, high energy by different techniques. All these things he explained graphically very nicely. Our participants, maybe from students community, maybe from faculties of different institutions over the India, actually enjoyed a lot. And we have actually learned many things from his discussions about the working principles of lithium ion batteries. He showed these things by animation process and practical capacity, how it is always less compared to the theoretical one also. Uh, in a word, actually, I may say that we have actually got all the information regarding that battery. Thank you, sir. Thank you very much for your very
Thank
nice and informative lectures. We all enjoyed a lot from your lectures, and we wish in near future also we will actually will get you, and we will request you. We will be in touch with you like this. You just suggest us and give us more lessons. Our students community will be actually will wait for that. Second lectures was given by Sushantanu Purohit, Assistant Professor, Department of Physics, University of Chittagong, Bangladesh. He is actually very dynamic professors. So far I know, I communicated with him, and he responded very well. He is very very kind one. When I actually told mm, 4 or 5 days ago with the students community that many educationists, uh, physics educationists are coming from Bangladesh and Sri Lanka. They were very much excited to hear you, sir. His topic was advancement of physics research and physics techniques in pandemic, and especially on the dosimetry in small fields. He has also given very nice and unique lectures on that particular topic. Students encouraged and actually learned many things. What actually they are using frequently about their in their mobiles, and many things are also we actually sorry, not mobiles, about the treatment purpose, about the radiations, and what we thought. This many things are there in our syllabus also. That's why students community especially enjoyed a lot how the radiation is actually very much useful for the viral treatment process, whether it is possible or not. Many radiation therapies, about its types, different diseases, about the quality assurance, everything actually he explained very nicely, diagrammatically as well as many graphically. He represents many data. All are established facts. So overall, actually, a very nice and unique talks we witnessed, and thank you, sir, for your stimulating lectures.
Thank
We
you.
all, we all. I'm actually from the organizing committee. A big thank is given to you, and we want to express our deepest sense of gratitude to Shantanu sir. We expect you in near future also. And
Thank you.
at the last, Dr. Vijayandev, my colleagues from RKM Kulashaw, he has also explained many things today. Some of the things actually from his deliberations. So we are using, but many things we know uh, about the online educations during and post-pandemic, and some pre-pandemic case also. A brief overview has been given by him, and all details in all fields about the digital technology-based educations, innovations, all these things he explained, and how actually the online systems help us in learning. Uh, Very carefully. He explained everything, different tools, how can be, how is it available, and which are free. How can you store the materials in different sections? Everything he explained very nicely. Thank you, Bijan sir, for your valuable talks and enrich us a lot from there. And we will use, definitely we will use the things of what you actually explained today about the digital libraries and others. Now, I acknowledgements are due first and foremost to all the committee members, Department of Physics of Government Degree College, Dharmanagar, Women's College, Agartala, ICB College, Belunia, Ramakrishna Mahavidyalaya, Kailasho, Tripura, India, for their constant reinforcement to organize such events. And very special thanks to Professor Arunodoy Shah, former Vice Chancellor, Tripura University, and the present Chairman of State Council of Higher Education, and our Director, Sir, of Higher Education Department, Government of Tripura. They have given actually their valuable time to us yesterday. We are thankful to them. It is a pleasure to acknowledge Sri Gautam Darshan, the president of this event, principal of our Dharmanagar Government Degree College, Monideepa Madam. She is the principal of Women's College, Agartala. Dr. Bimalendu Ghosh, sir, principal ICB Belunia. Dr. Pinaki Pal, sir, principal in charge RK Mahavidyalaya, Kailasur, Tripura, India, for their valuable suggestions. They always have energized throughout the process of the event. Especially our principal sir also, when he talked or when he actually gossiped with us, constantly he encouraged about the organization of such type of educational events. We are very much thankful all you sir. And my thanks uh, goes to all the honorable uh, invited speakers, those who have given consent to us, and they have actually sparing their valuable time with us. Dr. Monira Kubra, Madam, Associate Professor, Physics, Rashtriya University, Bangladesh. Dr. Nirmal Kumar Sarkar, Sir, Department of Physics, is the Associate Professor, Women's College, Assam. Dr. M.J.M. Jafin, Sir, from Northeastern University, Sri Lanka. He is also the senior lecturer, Department of Physics. And today's three speakers, Shubhrata sir, Kollan University, Shantanu sir from Chittagong University, and Bijan sir from RKM Kailasur. From my heart, corporate heart, I thank all of you, and we hope in near future also. When I request you, you please give consent to us and enrich us like this. We are always looking for your more lectures in future experts also. Thank you all. Big thanks. And one thing, actually, I have not given you the thanks to the participants also. I'm sorry. Uh, I am very much happy to see all the participants friends who are present over here since from the last from yesterday's. So I am profusely thankful to all their moral supports. They have actually encourages us by participating, by constructing comments, and by active participations in all respects. So I thank all of the participants, all of the speakers, all of the members, those who are directly and indirectly involved throughout the sessions, all the sessions. Thank you all. Thank you all. Please unmute. Raghu sir, unmute.
Expressing thanks and gratitude to each and everyone, all the members of the organizing committee, and invited speaker, and all the others. And actually, we are happy that our principals are joined with us, and he is always inspirational. He is leading from the front, is suggesting us, advising us, supporting us in all respect. Actually, whatever program we would like to conduct, we would like to initiate, he is supporting from the very front. That's why actually we are grateful to you, sir, also. So I now request you, sir, please share few words and finally end officially the end of this international event. Principal, sir,
Yeah,
please.
thank you. Good afternoon to all in this today's international conference of Government Degree College Dharmanagar, Tripura of India. All dignitaries, all resource persons, conveners, all coordinators, participants, and all my colleagues and my dear students. We are at the end of the today's e-conference. End session is going on. I am very much thankful to all educationists, resource persons. Without them, it was quite impossible to conduct this international conference. Your positive response made us proud. Hope in future our college will get positive response from you like today. Thank you all, sir and madams. Congratulations to all participants, especially all the stakeholders in education sector. Your active participation made our vision fruitful. It is fact that due to shortage of time, we could not respond of your all queries. Keeping in mind of this matter, we will organize our next webinar, workshops, etc. in near future. The member of organizing committee, coordinators, all directly or indirectly related to this e-conference, thanks go to all of them. Without their active cooperation, it was not possible to us to conduct this digital program. Thank you all my colleagues from all colleges of in Tripura. I hope this program is very much successful. We enjoy this program very much, and the participants could update and enrich themselves through this conference. Very soon, we will organize webinar, conference, workshop on physical science, biological science, humanities, commerce, physical education, etc. related topics. You all are invited. With these few words, I conclude my speech and declare the end of this today's international e-conference of Government Degree College Dharmanagar, Tripura in India. Thank you. Thank you. Namaskar. Can I leave? Okay, can I leave?